It's 2:01, and no new people are joining right now. Probably there will some people join a little bit later, but I guess we don't want to get behind our schedule. So I just want to give a very warm welcome to all of you to our virtual BotSE 2022. It's already the fourth international workshop on bots and software engineering. All four of them were co-located with ICSE. We have this roughly half day of discussions on bots and software engineering. It started with this crazy idea that I had a couple of years ago that I saw these things on bots appearing here and there, and I thought maybe a workshop on this topic would be nice. And I contacted Imad and said maybe that's a good idea, and he said, yeah, sure, let's try it. And yeah, I'm really happy that this turned out to be something that we could continue, and it seems like we might even continue it next year to a fifth one, but we can discuss that in the closing. What you think about continuing this kind of workshop? I have a couple of introductions and announcements in the beginning. First up, of course, if you want to follow up on social media, we'll have the BotSE workshop Twitter account, and we will use hashtag BotSE 2020. So we invite you to use that as well. If you tweet about something on the workshop, we very much encourage you to do so. I think it's good to also give people who are not able to participate in the workshop some idea what's going on here, and I think that's always nice. At least I enjoy this. If I go through my Twitter stream and I see interesting stuff from events that I was not able to attend. Yeah, so who's organizing this? So I'm doing the opening. So I'm Stefan Wagner. I'm from the University of Stuttgart in Germany. I co-organized this with Marielle Wessel from TU Delft in the Netherlands and Tom Mens from the University of Mons in Belgium. We had great support from Mehdi Golzadeh at the University of Mons for the publicity, and again, Ahmad Abdel Latif as web chair from Concordia University in Canada. Thanks to my co-organizers and the chairs of these various posts to bring this about again, and I'm really happy how it turned out. We also have a steering committee. So actually, these are the three early organizers of BotSE. So Emad already mentioned he and me. We did organize the first one, then we put Marco on board for the second one, and then we decided maybe this can be a longer term thing, and we thought we tried to form a steering committee that just gives the information and knowledge and experience from one organizing team to the next, that we have changed and that always the same people are organizing it. So the plan is, if we have a fifth one next year, that I'm rotating off from the organizing committee, and we are, at least I hope we are, we try to be a very open community. So if you're interested in helping in organizing BotSE in the future in one role or the other, please just don't hesitate and contact us. We're always looking for motivated people to work with us on this. I mean, it's not a big endeavor, but still it takes some work and effort, and we are very happy to include you if you're interested. It would not have been possible, of course, to run this thing without people serving on the program committee. So we did have paper submissions that had to be reviewed, and this was the list of people who helped us. Again, we try to be diverse and include new people that have been on the committee before, who are active in the community, of course, and work on these topics. And again, also to these people, very much a thank you for all the great reviews, for bringing in the reviews on time. It was, again, a very pleasant experience to work with you. Thanks a lot. And while I'm thanking people, I also want to thank everybody on the ICSE 2022 organizing boards that helped us in all these different ways. We cannot be there in Pittsburgh and cannot enjoy what is organized in Pittsburgh itself, but nevertheless, we had a lot of support from ICSE overall and on how to promote the workshops and the publications and so on. So thanks for that, of course, as well. So what is BotSE about? We have this rough list of topics, so we don't try to be extremely exclusive, but invite everybody who's working on bots in software engineering, but to give you a rough idea, what we invited people to submit about is the usage of bots, for example, to derive software requirements and documentation in the context of various quality attributes like reliability, safety, security, and so on, to support various activities in, for example, continuous integration, deployment and delivery, in software testing and maintenance, but also in supporting and answering developer questions. And then we are also very interested in the usage of these bots, of course. So use of for research on software engineering bots in terms of human-computer interaction, for example, privacy that is related here, or ethical aspects of using bots. We're interested in a practical experience in developing bots. So we, of course, often not only researching about bots, but a lot of us also build our own bots, trying to support new activities or different kinds of tasks in software engineering. And therefore, we are also interested in these experiences and also experiences in using bot frameworks in software systems. Our submissions, publications are not the most important thing about a workshop, I think, but I do believe it's healthy and helpful to have these things, to write it down, to have something concrete to discuss about. And so we always ask for papers as well, and we had 11 submissions, which also I think is a very nice number for a workshop. We got 8 acceptances out of these 11 submissions, so 73% acceptance rate, which again I think is perfectly great for a workshop. There sometimes are papers not really on the topic or just from the quality not good enough. So I think we need to sometimes sort some out and say they're not something we want to have presented at the workshop, but most of them are really, really nice papers, and we hear these 8 accepted ones. We had 3 to 4 reviews per paper. It's also something that's important to us, that we have a lot of feedback to our authors. I think that's the other thing that I really want as a workshop participant, to get a lot of feedback on my work. It's often work in progress and not fully finished, and something where I can still use this feedback very well. The diagram shows the authors of all submitted, so the countries of authors of all submitted papers, which I think also shows nicely that although the co-organizers now all are in Europe, we are not a European workshop, we are really international, including North America and Asia in this case, besides Europe. And we are also very happy about this, that we also have diversity in terms of authors. Some more notes. I guess you're all experts on virtual meetings now, but I just wanted to mention that you think to mute your microphones while you're not speaking, so that we have an overall low noise level. And to encourage you to also use the chat in Zoom. So we will mostly monitor the chat in Zoom to try to bring in questions and comments from there. We are a small enough group that it's totally fine that you also ask your questions directly, turn on your video and ask these questions directly. Or if you're more comfortable with that, and maybe sometimes something comes to your mind, you just put it there. It's also totally fine to put these into the Zoom, and we try to monitor that and bring these also up to the presenters after they finish their presentation. We are already making a recording of the whole workshop. We will ask all the speakers, of course, to give their consent. And if we have this, we will make those parts of the video publicly available. If you ask questions, just be aware that you might also be on this video. So if you don't feel comfortable with that, maybe resort more to the chat. Otherwise, we will just try to make as much information and experience of the workshop accessible to also people who are not able to participate. Probably have seen our website, just that you know the program is also on BotSE.org. If we can, we will put the videos there and have preprints already there of all the papers. And if you need any information on the workshop, it should all be there on BotSE.org. Quick overview of the program. So right now we're still in the opening, and I'm already running a bit over time, but I'm finished very soon. And then we directly go into the first paper session, where we have 3 presentations until 15:10, and then we have a 50-minute break. Then we have another 3 presentations where we have a lightning talk. So we also invited talks where there's no paper that's going to be published, but just something people wanted to discuss. And the third talk in this session will be our invited keynote by Peggy Storey, which we're really, really happy about to have her here, because she's also one of the very active researchers in the bots area. Then we have another break of 15 minutes, have another 3 paper presentations, and then round up the workshop with a tutorial by Mariatta Wijaya on Say with Bots. You will hear more about this later, and have some minutes at the end on open discussions, topics that are relevant for us, interesting for us, and of course the closing of the workshop. Are there any questions, something you want to discuss before we move into the first presentations? No, everybody happy? Okay, great. Then I will stop presenting and I ask the first presenters of the paper on the accuracy of bot detection techniques to share their screen. Who's presenting the first one? Is it Mehdi?
Yes, it's me, but your screen is still shared.
Oh, I have to stop. I'm sorry. Okay.
There is an error. The host is disabled participant screen sharing.
Really?
So
can you give him the right sequence?
Presenters should be host, or it should be added. Oh, now it's added. Okay, thank you.
Mehdi, can you try again?
Yeah, that looks good. So please start whenever you're ready.
Okay. Okay, hello everyone. I'm Mehdi. Sorry. Hello everyone. As you know, I'm Mehdi Golzadeh. I'm a PhD student at the Software Engineering Lab of University of Mons, working with Professor Tom Menz. Here I'm going to present the result of our study with Dr. Alexandre Likan and Natarajan Chidambaram about the accuracy of the bot detection techniques. Sorry. With the advent of collaborative software development, the step to produce a software is not like before anymore. And many developers contributing to the code remotely and asynchronously, and this distributed style of development and social activities of developers in social coding platforms has increased the workload of software developer and repository maintainers. To reduce this workload, developers adopt automated tools and to perform repetitive tasks in their development process. Such tools are commonly known as development bots or simply DevBots. They are being used to facilitate code reviews, code quality analysis, communication, and dependency management, and so on. Bots are quite prevalent, and in one of our studies, after rating 5,000 accounts, GitHub accounts, to create a ground truth dataset, we found around 500 bots. And in another study, Vessel et al. Also reported 93 bots in 351 projects. So they are quite prevalent. And also we analyzed in a small dataset of GitHub repositories, and we found they are among active contributors. So it's essential to study bots. Researchers have proposed and used techniques to, or simple heuristics to distinguish bot accounts from human accounts. For example, in one of our previous studies, we proposed a classification model to identify bots based on their commenting activity in GitHub. We also proposed a tool to facilitate the use of this model. They et al. Have used an ensemble technique to identify bots in GitHub commit activities. In another study, we proposed a technique and a tool to identify bots in GitHub commit messages called BotSE. Saodat et al. Have used the presence of a string bot in the username of accounts to identify bots. Another study of us based on NLP techniques. Recently, Abdel Latif et al. Have proposed Bot Hunter to identify bots in GitHub, which is published after this after submission of this paper. There is also GitHub account type that indicates bot account, and the list of bots, which can be a method to detect identify bots. In this research, our main goal is to answer two research questions. Research question one is how to create, how accurate are bot detection techniques. Research question two, how prevalent are bots among the most active contributors? And research question three, how active are bots in terms of commits? To do so, we need a data set, and we used a SEER tool to, which is basically a data set of GitHub repositories and their specification. We queried repositories with at least 200 contributors, not for have been active at least 2 months of previous before our study, and has at least 1,200 commits. And we created a data set, a small data set of 20 repositories from diverse programming languages like JavaScript, Python, Java, PHP, Ruby, and Nets, and a diverse set of projects like type of project like packages, plugins, and tools. And with this 27 repositories in total consist of 175,000 commits and from 9,500 contributors. We use these 5 techniques to identify type of accounts in these repositories. Actually, most active accounts in these repositories, because there are a lot of accounts and it was not possible to check all of them. And the result is shown in this figure. In this figure, we only report accounts that have predicted at least once by predicted as bots once by one of the techniques. For ease of read, I make it a bit larger, and I want to explain some of the observation in this figure. From the figures, we observe that the list of bots, bot suffix, and GitHub account type are safer techniques in the sense that they don't wrongly classify human contributors as bots. At the same time, they miss some of the a lot of bots in the repository. We also observe that BotSE effectively captures most of the bots, but at the same time, it has some false positive cases. BotSE shows a similar behavior, but given that BotSE is mainly designed for bots that are active in commenting activities, the result is less accurate. Except for a few cases, the 5 techniques do not even agree on whether a given account is bot or not. But at the same time, only 4 of the actual bots are not detected by any of the techniques. We note that none of the techniques is perfectly effective in detecting bots. So we combined all of these techniques to create an ensemble bot. Ensemble classifier, sorry. The results of the accuracy of this ensemble classifier is compared to the previous model and a baseline 0R. We trained this classifier using a small data set that we created, and we use cross-validation to evaluate it. We see that there is a bit of improvement in the result of this bot identification, and the F1 score of this model is better than each SOL technique. For our Q2, how prevalent are bots among the active contributors? This figure shows the active accounts in these projects, top 20 active accounts in these projects. We observe that all of the considered projects are making use of bots. Some of them even have 4 different bots among top 20 active contributors. And 18 out of 27 projects have a bot in the top 3 contributors. We see bots actually are among active contributors. We use our ensemble model to identify these bot accounts in this set of repositories, and we see this model still misses a non-negligible amount of bots in this set of projects. And also the model classifies some human account as bots wrongly. So we have still, our model is not very optimum yet. We have 7 human contributors that are detected as bots. As for research question 3, that we want to, the main goal is to quantify the number of commits made by bots in their respective project. The figure reports on proportion of commits made by each account. We distinguish between human contributors and contributors that classified as bots, bot contributors, and bot contributors missed by our ensemble classifier. Our ensemble model is able to detect most of the bots. However, it still misses some of them. And these missed ones are responsible for 4.7 on average commits of in their respective repositories. On the other hand, ensemble model also wrongly classifies 7 human contributors as bots, which are on average responsible for 10.4% of commits. On average, approximately 16% of commits in these projects are made by bots, even if the proportion of bots are 9% of all accounts in these projects. The main conclusion is that bots are responsible for a large proportion of commits. For summary, in this study, we compared existing bot detection techniques. We showed that none of them techniques is perfectly effective in detecting bots. We created an ensemble classifier model based on these techniques. We examined the prevalence of bots among active contributors of all these projects that make use of, all these projects show that they make use of bots. We found that bots are among the most active contributors, and they are in charge of a large proportion of commits. As for future work, we aim to complete this model by adding Byman, which is proposed by Day et al. And we aim to compare our ensemble model with Bot Hunter proposed by Abdelatif et al. We aim to create a larger data set of repositories and evaluate our model on a larger set of accounts. Also, we aim to use more advanced ensemble classification models to create our model. Thank you for listening. I would be happy to answer if there are any questions.
Thank you very much. We have a couple of questions in the chat, and I think I'll start with them. So there's one from Tom. He wrote, in your presentation, you compared the prediction accuracy of 5 different bot detection techniques.
Okay, I haven't studied the paper recently published, and I don't know about the detail, but I know they have used the model we provided and the Bodyguard tool. That's one of our studies. They included in our study in this paper, but I haven't compared the result of our paper with that paper. I hope we can get the data set that they used to be able to compare our model with their data set, but we haven't done anything about it yet.
Okay, thank you. Then I have a question from Walid. Are the study detection techniques more or less accurate than techniques to detect non-software engineering bots?
Actually, we haven't compared our model because there are a lot of bots actually in Twitter, in also in Wikipedia. There are a lot of bots, active bots. There are active bots in the area of chat bots, but we haven't compared our model. I'm pretty much sure that our model cannot detect bots, that chat bots, because our model works based on similarity of comments. That is not the case in the chatbots. But I believe it can detect bots in. I'm not sure. I'm not sure to if I can claim this or not. But I was going to tell if this can detect bots in Twitter. But yeah, I haven't compared them at all.
Well, it is nodding, so I guess he's happy with the answer. Then
thank you. It's just an interesting thought that the numbers are interesting, but I was wondering, are we better or worse than the others? That's the question, basically. Of course, not only to Mehdi, maybe something to discuss later also.
Mm-hmm.
Thanks. Then I have something from Alexander. Your presentation seems to highlight inadequacies of the number of commits as measure of importance of contributions. How important are the contributions made by bots for human developers?
I'm not sure I got the question.
I mean, Alexander, I think you can. I don't have to paraphrase you. Do you want to jump in?
Yeah, sure. Thank you very much for introducing me, Stefan. So if the bots, what you are showing is the bots are doing lots of things.
Mm-hmm.
But you are not showing that those bots are doing useful things. So one way to deal with this would be to say, bots are just producing relatively unimportant things, so we should not be looking at the number of commits as a measure of importance of contribution. We should be using some other measures. So the question would be then, how important are those contributions of the bots? Are they actually doing something which developers believe to be important, or are they doing some kind of minor routine-like bookkeeping?
Actually, we haven't analyzed this. The aim of our study is to detect bots, because as you told, sometimes they are used to do minor stuff, but to inflate their activity of some developers. So when the contributors or maintainers of repositories, they aim to attribute contributors' activities. They want to acknowledge their activities. Sometimes the contributors use bots to inflate their activities, which is not good. And our method shows that we propose methods to identify bots. So it's important to identify bots. But as you said, this can be important task. These tasks can be minor or trivial tasks that but we haven't studied them.
Okay, thanks. I think we are running a bit out of time. I noted down that we might have this discussion on SE bots versus non-SE bots a bit later on. And I would like to move on to the next talk. Mehdi, are you giving that talk as well?
No, Natarajan is going to go.
Okay, then I would invite him to share the screen. And we have the second talk on leveraging predictions from multiple repositories to improve bot detection. Please go ahead.
Can you see my screen?
Yes, yes, you can just make the presentation view.
Yes.
Yes, perfect. Looks good.
I hope it's better. Okay, thank you. Hello all, welcome to my presentation on the topic leveraging predictions from multiple repositories to improve bot detection. This project is done by Alexander Decan, Mehdi Ghazaleh, and myself, Natarajan Chidambaram. I am doing my PhD in the software engineering lab at University of Mons, Belgium, under supervision of Professor Tom Lenz. Collaborative software development is what it means is mostly developers come together to contribute and develop a particular software artifact. So here, GitHub is one of the social coding platforms which promotes collaborative software development. It has many artifacts such as code, pull requests, issues, discussions, and so on. Here, contributors, human contributors and bot contributors both come together to develop software artifacts. Here, bots are mostly used in software development to perform repetitive, error-prone, and tedious tasks. Tedious tasks means like it requires a lot of manual work, which can be automated. So bots can do these jobs. For example, dependency updates or code testing can be done by bots. This also reduces developers' workload by automating the tasks, and also this increases the productivity of the team by automating the task again, and this improves the developers' quality as well. So the need for bot detection, because as we saw in the previous presentation as well, bots are prevalent in software development, in collaborative software development. In recent study, it is also found that bots perform 12 different tasks, and there are also many bots that do that. And bots are also among the top contributors in many projects, especially in GitHub. So, and also developers need to know, especially the newcomers and the users deserve to know whether they're chatting with a bot or not. And this is also useful to accredit human contributors instead of bots. This is especially useful for the funding organizations who would like to accredit the human contributors rather than the bots who are in the projects. And this also helps to reduce bias while conducting social technical analysis, because we need to separate the bot accounts and also the human accounts to know and conduct the social technical analysis. This also allows the researchers to isolate bots and to study their impact, their performance in the project, and so on, and other bot-based studies as well. Bot classification model, one of the models developed in our lab, which works on predicting the type of the account based on similarity of comments and using the features such as number of comments, number of empty comments, patterns among them. And this model is trained and validated on 5,000 GitHub accounts, which has 527 bots among them. This model also achieved a precision of 0.94, recall of 0.91, and FN score of 0.92 for identifying the bots, and 0.99 in all the three measures for identifying the human accounts. This particular model is named Bodega, which we have as bot identification tool, which gets the GitHub repository usernames and the repository name, the API key for querying, and the other parameters. It goes into each and every repository queries the comments made by the authors, by the contributors in issues and PR, and then the pre-trained classifier would predict whether a particular account is a bot or a human. So all the accounts in the particular repository will definitely fall under a particular class, whether it's a bot, human, or unknown. On the right side, right bottom, we have a sample output from Bodega, which is executed on the server repository. And here we can see particular users, particular contributors are predicted as bot, some are predicted as human, and some predicted as unknown. This unknown prediction is due to the fewer number of comments. Bodega has a limitation where the contributor has to make at least 10 comments for them to be considered for pattern analysis and recognition, so that they can be predicted as human or bot. This brings us to the problem statement. For example, if we consider 3 different repositories where the same account is present in all the 3 repositories, the account is considered as human, predicted as human in one repository, same account is predicted as bot in another repository, and the same account as unknown in another repository. So which type do we classify this account as? The problem statement is the same account can have different predictions in different repositories. So this is because Bodega acts on repository level rather than going on different multiple repositories. So we framed 4 research questions to answer our problem statement. First one is to see how frequently are contributors active in multiple repositories. For them to be classified as a bot in one repository, human in another, and unknown in another, they have to be present in different repositories. So we need to know how frequently are they active in multiple repositories. The second research question is to see how frequently the contributors have diverging, that is, they are predicted as a bot in one repository, human in another repository, or incomplete predictions, that is, bot in one repository and unknown in another repository. The third question is to see to which extent can we fix these diverging predictions. And the final question, as we all guessed, we need to say to which extent can we complete the predictions, that is, changing unknowns to bots. For this, we depend on Cargo Package Manager for studying the data. The first step, what we did is to identify the packages that have a link to homepage or documentation. This is based on the assumption that mature packages definitely do have a link to a homepage, or at least they should have a documentation page to explain what is the usage of package and how can it be used. And that's what we consider to be mature package. And the next filter, we found 94% of the packages were hosted on GitHub, and then we removed duplicates. That is, 92% of them were for unique repositories. What this means is different folders of the same repository correspond to different packages in Cargo repository, Cargo Package Manager, sorry. So to filter, as we are concentrating on a repository level, we removed the duplicate repositories and found 20,000 odd unique repositories. Here, we also had another assumption saying that the number of issues or PRs should be greater than 100 for the particular repository to use bots, because they need to have a usage of bots. And for the particular repository is pretty big, and then we can find the pretty big usage of bots. And finally, we ended up having 1,039 GitHub repositories, and among them, there were 147,000 pairs of contributor repository pairs, and which corresponds to 57,000 odd unique contributors. Anyway, these 57,700 contributors, everyone did not make enough number of commenting activities. Only 8,000 contributors had enough commenting activity. That is, they had minimum of 10 comments in at least one repository for them to be classified and for us to use Bodega. And the result of this, to answer the first research question, is that at least 1/3 of the contributors were found to be active in multiple repositories. And surprisingly, 211 contributors were active in 10 or more repositories. To answer research question 2, how frequently our contributors have diverging or incomplete predictions, we took the accounts that are predicted as bot at least once. and we took only those, considered only those accounts, and we found 229 accounts to be predicted as bot at least once in at least one repository. And this was done because we need to improve the bot detection, and the vice versa, that human prediction false negatives is not feasible as we need to work on other 8,000 odd repositories, 8,000 odd accounts, and we need to form the ground truth for them as well. From this, we found the ground truth, and we found around 54 humans and 6 bots have diverging predictions. That is, 54 humans were predicted as bot in another repository, and 6 bots were also predicted as human in another repository. And 36 humans and 27 bots had incomplete predictions. That is, they were predicted as bot or unknown, but never as human. To answer our third question, that is, how to which extent can we fix the diverging predictions, we distributed the points on a chart where number of bot predictions can be on the y-axis and number of human predictions on the x-axis. The orange triangles are true human, that is from the ground truth, and the blue ones are from the true bots. On applying Bodega, we had a precision of 92.2, recall of 96.8, and F1 score of 94.4 when comparing the performance of Bodega with the ground truth and its prediction as well. To fix the diverging predictions, we depend on a very naive classifier, that is wisdom of the crowd principle. In short, it's OP. So wisdom of crowd principle is nothing but we allot a particular type of the contributor to be the type of contributor corresponds to the type in which it is majorly classified as. For example, if a bot is predicted as, if an account is predicted as bot for 4 times and human as 3 times, then we classify that account to be a bot. If in case of clashes, that for example, there are 4 number of bots and 4 number of human predictions for the same account, we give the benefit of the doubt to human. That is, they'll be predicted as human itself. And this, by applying this very simple model, we found it improves the performance by actually F1 score to be to 99, and recall to be 100, precision to be 98.1. And this simple model seems to improve the performance of Bodega itself. Next question, to which extent can we complete incomplete predictions? And the same principle here, we have points where the orange triangles correspond to human, blue triangles correspond to bot. And here we have chosen a threshold of 3+ bot predictions. That is, the particular account should be predicted as bot at least for 3 times in 3 different repositories, and that should be the majority of the time it should be classified as. Then we can say the particular account is a bot. To summarize this work, we first saw how useful is to identify bots. This is mostly useful for researchers and practitioners, such as they can be used for accrediting the human contributors and so on. Bodega identifies bots based on the comments, issues, and pull requests in a particular repository. As it works on repository level, contributors active in multiple repositories can have multiple predictions, that is bot in one repository and human in another repository. So this, to fix diverging and incomplete predictions, we proposed the model called wisdom of the crowd principle, where we found through the results that it is effective at fixing the diverging predictions by just having a majority classifier, majority class, and it is also found to be promising to address incomplete predictions. However, this incomplete the threshold of 3+ bot predictions is formed based on the ground truth and the observation from our data, and it has to be validated on a bigger data set to be used and generalization. To conclude, I would say that our proposed model is performing better than Bodega, and in future we will see if any other bot detection tool can be benefited from the same approach. Thank you. And I welcome questions. Thank you.
Thank you very much. I see questions in the chat. Let's start here. There's one from Tom. Is it a correct assumption to say that a mature package should have a homepage or documentation link? How did you validate this assumption? On which you base yourself for filtering the data?
Yeah, so here it's just an assumption because like for mature package, it is developed for people to use it. So without knowing what the package is doing or how to use a package, but definitely I would say the mature packages would definitely have them. And this is just an assumption, and this has to be validated again.
Okay, so you didn't look at that. Okay. Another question from Tom. Bodega requires at least 10 comments in order to be able to provide a prediction for an account. If an account has less than 10 comments in each individual repository in which it is active, but more than 10 comments in total in all of the repositories in which it is active, could this information be leveraged to allow Bodega to provide predictions for these cases?
Currently, Bodega cannot do this because it works on repository level. So it considers individual repository because it takes a repository name and then predicts the account type of account in that particular repository. But here, from the question, I could see that it is not about predicting the repositories. It is collecting comments for multiple repositories to predict the account type. So currently, Bodega cannot do this, and we could modify Bodega to consider comments for multiple repositories and predict the account type rather than leveraging the predictions made by Bodega. Hope this answered the question.
Actually, maybe I can be more precise on the question. The question is actually, so since, so basically the question was more like, would this type of another extension, so you looked at different extensions of Bodega to see if this could lead to better predictions. So my question is actually like a proposal for a new extension, but I don't know if it will be a good one in the sense that since, well, on the one hand, you might have like an account could be predicted differently in different repositories. So in that case, taking the totality of account comments over different repositories, will this actually allow you to provide accurate predictions if you would use this in the case where you don't have enough predictions from one single repository? What do you think about this, given that you have already done some similar analysis?
Yeah, actually, I think that could be done, but I fear that the concept of mixed accounts, we could miss the concept of mixed accounts as well, where a particular account is being used by a human developer and also a bot. Then if you're going to collect all the comments from different repositories and make a single prediction, then we would miss the concept of mixed accounts here. And currently, as I said, Bodega works on repository level, but collecting multiple comments from different repositories and making a single prediction for the account can be done, but I don't know how much feasible it would be. I cannot promise its accuracy as well.
Thanks.
Okay, maybe we can get one final question from Kasura. Maybe I missed it. Are the results coming from the test set or training set? From the results, it seems that the model is a bit overfitting. Have you also took a look at how you could reduce it?
Here, there is we haven't run any training or testing. There is just a very naive model, which is depending on the majority classes that is being classified to be. So suppose a particular account is classified as bot for majority number of times, then the particular account will be termed as a bot itself. So we haven't trained or tested or anything. We haven't done that. It's just a very naive classifier. That's it. Okay, thanks. And I guess we have to stop here. Thanks again. Thank you. Thank you. Nice talk and these great discussions on detecting and identifying bots. So we come to the third and final presentation in this session. Yes, Jorge is giving the talk on a digital mentor towards a conversational bot to identify hypotheses for software startups. And Jorge, you can start whenever you're ready. Jorge, you're muted. You're muted.
Thank you, Stefan. Yeah, so start over again. Well, thank you for the introduction. I'm Jorge Menegatti, and I'm a postdoc here in the Free University of BotSE in Bolzano, Italy. And I'm here to talk to you about our digital mentor. So for software startups. So I want to start. First, define what we mean by software startup, because nowadays the negative side of studying something really popular now is that everybody now says that has a startup. So what do we mean by startup? We are looking at organizations developing, looking for a repeatable and scalable business model for innovative. This is a key word: innovative, software intensive, because it's a software startup, of course, the product or service it develops. So as I said, innovation is a key word here, because when you are developing something that already has a known business model, you already know what to do. So imagine you're creating a new software factory. You know that you will develop a piece of software by demand. You develop it, you receive the money, and that's it. Of course, there are maintenance and so on. But when you're developing a novel business model, a novel product, this brings a lot of uncertainty. And uncertainty is a key challenge for software engineering. And that's what we in our community looks for, to help software startups to cope with this uncertainty. And one of the key tools to cope with that is the idea of experimentation. So with experimentation, we can reduce uncertainty. What do we mean by experimentation here is to identify critical product assumptions, transform them into hypotheses, and test them with experiments, trying to support or refute these hypotheses. To do so, we have several practices such as A/B testing, canary release, problem and solution interviews. So here we are talking about experiments in a broad sense, not so restricted as in research, in scientific endeavor, that has a clear definition, control experiments, and so that we hear a lot in this field also. But here we are really focused on having being data-driven decision-making, rather than just rely on the opinion of one or two people or just the team and so on. Experimentation has, the research has shown that in the industry, it follows some similar sequence of steps. So first, you have to identify, prioritize, and specify hypotheses. You have to design your experiments, have to execute them, and once you execute them, you got the data, you analyze it, and you come back and see if you confirm your hypothesis, you refute it, or you create new hypotheses and so on. In our previous research, we call this first step as hypothesis engineering, and we identify hypothesis engineering as a parallel to requirement engineering that we are all aware of. So we also identify some activities in this process. So as elicitation, what we mean that is you identify your hypothesis, then you have to prioritize them, have to somehow communicate the hypothesis in your team. So you have to specify that, somehow document it. There are also techniques to analyze and manage them. Here we are talking about elicitation, so how to identify hypotheses, how a team, especially here about software startups, how can they identify the hypothesis they should test when building their software. So in our previous research, we developed a technique called HiMap to identify these hypotheses. It's based on some results we got that the founders have like a mental representation about the market and the customer, the users they are building that product to, and they use this mental representation to forecast and preview how these customers will behave and if they will use and they will pay for that product or not. And the goal of this technique is to make this view somehow evident, tangible in some way, and help these founders to challenge this view. So how is IMAP is done? So generally it's a facilitator. There is a facilitator outside of the company. It's better because when someone from the company generally is biased together, so it's not so common that they challenge some questions. So it's good someone from outside, and we prepared a predefined set of questions that they use these questions to, and based on these answers, they draw together what we call a cognitive map. And based on this map, they could create hypotheses. So here I created a simple map for, imagine for Uber. Of course, the hypotheses for Uber are now quite clear that they are valid, but it's easier to give an example to explain to you. And this could be done, if, of course, if you are developing Uber 15 years ago and so on. Just to give two examples of hypotheses that we could create from here is that actually each one of these errors leads to a hypothesis. So here, the one connecting riders, that one of the customers to one of the problems they identify is that riders have difficulty to order a cab. So let's imagine that we don't know about Uber. So if this hypothesis is not valid, it's really risky to build a product to implement what we know about what we know as Uber today. So this is one of the key hypotheses. Of course, there are others here. Another is that also if drivers really would be willing to make their extra income using their own cars and offering these rides. There's a problem with HiMap that we observe is that a good person to be a facilitator will be what we call what is called in the startup community is the mentor. So mentor generally is someone with a previous experience of startup, an entrepreneur that was successful or not, and it could bring this experience and transmit to the founders and the startup teams. But the problem is that they are somehow scarce, except in some really mature ecosystem like Silicon Valley, Israel, and so on. They are scarce, so it's quite common that we've had some contacts with startups during this during our research, and they complain that it's quite common that someone is a mentor, but he or she had the experience with traditional companies. They're not used to this digital entrepreneurship or these tools and so on. So it's really scarce. It's even one of the metrics to identify to define the maturity of a startup ecosystem. So our goal here was to replace in this research was to replace this human facilitator with the chatbot. So what is a chatbot or conversational bot? A chatbot is a system where the user interface is based on natural language that you try to emulate a person interacting with the user through natural language, of course. So generally it's talking about, it has two phases or two steps. You have to generate what the bot will reply, that the occurrences that is called, and to do that, the bot should understand what the user wants. So it's this step of natural language understanding. You generally nowadays this is done with intent classification and entity identification. It's quite common to see chatbots used for to get orders for different businesses. Like imagine that some a restaurant has a chatbot and receives the order from a customer. I want a margarita pizza. So generally the chatbot will read this and identify that the user wants to make an order, and we will identify what is the order. So what's the entity? So it's a pizza, what's the type? Then you could ask what time, and so several entities to identify. So here we present you the digital mentor. The digital mentor is basically, as I said, it's a chatbot. Here on the right, you see the conversation, the window that you can answer what the digital mentor is asking you, and on the left, it already draws you the high map. Here it's a bit of the conversation. So start asking the product, what are the customers, why this customer wants to use this new product that we are thinking about. So just a quick overview of the architecture. So generally you can use for this chatbot, you can use a whole solution like Rasa, but here, because we are developing also the drawing, the cognitive map, we brought part of the implementation of the state machine, like a state machine, to a web server. So it's a website, so it implements and it gets the user inputs and sent to the natural language understanding unit from Rasa to identify the intents and the entities that are being sent. So this state machine is basically so it's how the chatbot works. So it starts as initial, and each one of the states consists of asking a question and try to get the either an intent or an entity in this process. For instance, initial state is to try to get the name of the product, and then the chatbot will try to get this answer and extract the product name from the full answer, and so on and so on. So what's the current status of our implementation? So we observed that the intent, of course, we developed some possible answers and train this chatbot. So far, we observed that it was really hard to identify the intent, but the state machine as it is now, it's quite resilient with the errors. So it manages to somehow continue with the correct flow. But it was really hard to correctly identify the entity. And this is quite important to identify the pieces of the thing to really put that in the high map. So here an example. So the digital mentor ask why the riders want to use Uber and say, it's hard to find a cab in some places. So here we see that it puts just a piece of just to find, and not put the whole sentence or the whole piece to find a cab in some place. That would be the best thing to put. There are also some in this process of the current status, we've seen some challenges. It's really hard to break down the semantics here. So depending on what they are trying to answer, so it changes a bit. I'm a bit over time. So, and as I said, the entity extracting was really tough because there could be different answer structure also. So we are trying to be as natural as possible for the user, so they could, but this way they could answer direct answers, like just try to book a ride, or they could try to answer more detailed, because it's hard to find a cab in some places. And it's really, we've been really bad time trying to train that. And also the data set, we had to create a new data set for that because hypothesis is a new topic. And yeah, it was really hard to train the bot. So our next step is probably try to rely more on the state machine and less than the intent classification as we are already doing. And we are trying to, one of the ideas, of course, here, that was one of the reasons to present here is to get some suggestions to go forward. One idea is to try to restrict the freedom of the user to answer these questions and really get the answer and put in the high map. So that's all. Thank you. And I'm open for questions and of course suggestions. That would be really nice.
Thank you very much. I see one question from Tom. How could your approach extend and be applied outside of the Uber context, for example, in the context of software development bots?
Oh, I use it Uber just an example, but you can do with any other software startup, the idea is to use with any company or any team trying to develop a new piece of software or a novel piece of a new product, of a new software product. Yes. As I said, Uber was just an example. If I would have to train just for Uber, it would be easy. The problem, that's one of the problems because we want to make it useful for any startup. So there are many domains that we should train the bot to understand. So this is one of the challenges here.
Maybe I have another follow-up question if you want.
Yes.
So your approach was based on state machines. I was wondering, based on your current practice experience so far, if you found any limitations of using that approach, or was it rather the opposite? That
yeah, one of the limitations that as we already work with that is in a natural, let's say, in a natural conversation, it's quite common that a person maybe have a doubt here. Oh, I want to ask something, or what do you mean about that? So we already have some fallbacks for this type of requests by the users. But of course, sometimes the user might answer something. Oh, you asked it before that, and maybe that's a different answer. So this is a problem of state machine. So how can we make the bot understand that it should actually change the state and come back because the user is talking about something else? This is a restriction also.
Yeah.
But to be honest, I think at least on the research that we've done, most of these platforms for chatbots are basically implemented using state machines. But yeah, there are some limitations.
Okay. We could take one final one, and if nobody else has one, I was wondering a bit about to what degree this is really a conversation, because most of the examples you had on the slides were just, is this the case? Is this the case? And then an yes, no.
Yeah.
Is this something that how to what degree do we really need a chatbot? Or do you have an example of a more elaborate conversation that the chatbot would be having instead of
yeah, let
something?
me share again here. Here in the, so this is one of the, of course, this example is really short. In real scenarios, we have much more, more customers or more reasons for the customer. But this one here on the top right corner is one of the really conversational. So when the digital mentor start asking why. So here is when it really has to identify the entity. So what the user really wants to say here, and how I can convert these to the map. Yeah. Here we put a lot of yes or no, but initially we put the user can answer as different ways also. So, but
Okay.
yeah, here it's a bit where it's more, let's say, intelligent than a simple survey or something.
Okay. Then thanks again. And
Thank you.
thanks to all the speakers of this session. This closes our first session and brings us into our first break, 15 minutes. Marieli will show a countdown when we will be back for session 2 that is then chaired by Tom.
Yeah, so we'll start at 15:25. think that Marielle's countdown is 2 minutes behind since it's 15:25. So I hope not too many people are trusting the countdown. Anyway, so I'm the host of the next session. This next session is a bit atypical because it's a combination of one lightning talk followed by one normal talk, so a longer one, and then a much longer one, namely the keynote by Storey, for which we can all not wait to see it. In addition to this, the first presentation, so three of the 5 co-authors are there today. But the person that actually did most of the work, Neil Telles, so the first author that you can see on the presentation that's currently being shared. Unfortunately, he had to, I think, to do some exam or something today at exactly the moment he was supposed to present this work. So because of this exceptional reason, they decided to share a video to still give Neil the possibility to present this work to us through a video presentation. After the video presentation, so you can all, of course, as usual, start raising your questions through the chat, and the other authors of the work will be able to respond to the questions that you may have on this work. So I think, Marianne, you can start running the video.
Hello, everyone. My name is Neil Tellez, and today I will be presenting on Assure AI, a prototype application or bot that was built to help automate the detection and mitigation of biases found in machine learning models. The underlying idea of this app was to utilize a different approach to how biases can be detected or mitigated. When limited to your collection of data, AI models will be flawed with its selection of biases and its layers. Such flaws could be that many poor key decisions will be made in general when implementing the model in the real world on data as it has never seen before. And if it does make it to the real world, this could affect many people's lives. So instead of cleaning or filtering out data, we tried a new approach, which is that we traverse the model layer by layer through the nodes of the model, where we treat each node or neuron as a similarity estimator. And this approach we use will eventually allow us to gain an insight on what makes up the AI's predictions that would lead to detect and potentially mitigate biases under the hood. Our prototype bot aims to make use of this to be able to provide this service for anyone's machine learning or deep learning model online at any time. The program flow of how this works can be simplified into 3 steps. First, the user uploads their trained model's learned parameters to our interface and enter their credentials, such as their name and email, so that they can receive the results later on through their email. A PyTorch file will be saved as a binary large object or blob in an Amazon S3 bucket, and the associated unique ID for the blob is stored with the name and email on a MongoDB, which is a NoSQL database, along with any additional info on the type of model we're dealing with, such as if it's for computer vision or natural language processing, etc. And also with sample data to verify results of the model before sending it out to users. Second, a backend process runs and will periodically check for any files needing to be processed. If a model needs to be processed, then the neural network approach, as mentioned as before, of treating the nodes as similarity estimators, will be used along with verifying the results of the updated user's model using the user-provided sample data that we mentioned in the previous step. Lastly, after processing the model, we can send results of the potential biases found in some key layers or nodes. Also, if requested, it could send user an updated model with the modified nodes. This would be the mitigation part of the biases. The front end and back end of this bot makes use of the MERN stack. MongoDB, as mentioned before, as our database, React.js for the front-end interface, and Node.js for the back-end, which makes use of the Express framework, helping us create routes to send post requests as users send their models for processing. These models, or PyTorch files, are uploaded to an S3 bucket along with the related data for verification of the model's results when it undergoes processing. This was done using AWS SDK, Software Development Kit. And for an easier visualization, here's the architecture of the prototype bot. It is also important to note that this bot is a whole system that would be automatically managed by Kubernetes. And as such, the parts of this system can be described as running pods or virtual machines, except for the Amazon S3 bucket where we store the PyTorch files and related data for the verifying results of the modified biases. We make use of Kubernetes because it will then make this system very easily portable, along with its many features that we can make use of, like zero downtime deployments, fault tolerance, high availability, scaling, scheduling, and self-healing. On the bottom right, you can see the pods we create. The reasons we decided to push files to AWS S3 is because when you've got a high volume situation, such as if many users are using this prototype, we want to make the most reliability from our server, and the best option is not to store the files directly on our Node.js server, but instead to push the files instead to a separate file server as soon as we receive them. The file server can be a cloud storage service, such as the AWS S3 as mentioned before, or it can be any database that supports blobs. Along with the MERN stack, in a separate Kubernetes pod or Docker container, we can run a Python script. Well, we run a Python script which will process the available PyTorch model files or objects in the bucket, and this is done by treating each process as a task that a Python library called Celery processes. This library also utilizes the neural network as mentioned earlier that looks layer by layer to detect biases in a model, along with verifying the results of the model's improvement of mitigating its prediction results on a specific class of the user supplied data. After the processing the data, it will then email the results to whoever requested the data to be processed. So, onto looking at future prospects of this prototype that I outlined before, there's much needed development on the task processor that uses our neural network approach. So far we have only tested on our own model, which is an end-to-end object detection with transformers. That is the name of it, and this was created by Facebook in 2020. And we hope that this prototype system that I showed the architecture for would help to make some type of service available to everyone's model anytime and work automatically anywhere. And so finally, I would like to say thank you for listening to this presentation, and thank you to my professors, Dr. Kumar and Dr. Lee, for allowing me to work on this project.
Okay, thank you. This presentation is over. So except for myself, I haven't seen any questions so far in the chat. So let me start by asking myself my own questions. So first question I had on this is, well, it's actually related to what actually is the definition of a bot, because in this particular case, I think it can be argued that I see that actually what is proposed here is a kind of cloud service that users can be using for analyzing their AI models. So should this actually be called a bot, or is it something else? So I don't know if the one of the authors can comment on this, or can just unmute yourself. I don't know who wants to answer this. Not hearing anything. Yeah.
Okay, yes,
Hello.
actually in the summary, we originally had one slide talking about 2 years ago, we built a chatbot, and that idea is from chatbot. Chatbot is kind of soft robot. When people are thinking about robot, they're thinking about a robot imitating human. So chatbot is just a soft piece of it. It's a software part. So in our idea is the robot is something that can autonomous making decisions. And in this case, is that users can drop their AI component, just like an AI in the production line, drop the AI component to this robot, and the robot will inspect, and then will come out with a answer. Is this how much bias you have and how to improve that? So that's why it's a robot. Right, just imagine a robot like an inspector robot. Right, and
okay.
inspecting the AI components. Right.
Yeah. Okay. Okay. Thank you. I think it's an interesting question that that opens a discussion about when exactly should something be called a bot. So perhaps we could have this as a discussion later on in the open discussions session later today. Another question I had was, well, perhaps I will first ask a question from Stefan to avoid me asking all the questions. Why is it a good idea to implement it as a bot and not as another kind of service? I don't know if Stefan, if you want to perhaps clarify this question. Is it Stefan?
Right. So my question is, what's the difference in your view?
A bot for me has usually something like a kind of not really a persona, but it feels like a really an independent agent instead of something neutral that I just communicate with, and maybe also not necessarily, but often something that has some kind of natural language interface. So would that be?
Our main idea is that AI can fix an AI without any human intervention, and this is all artificial intelligence is about. So, let it, go by itself, swim by itself like a ship. And so far, we only tested one model. As you see, we only present small talk. We don't really publish anything here. Application is in very good stage. So, why we don't present demo? Because our student is actually very bright student. He already hired by Amazon, currently graduating from King University. And, so that's his main brain to it. Obviously, we advisors, we are, working in the area of AI and guide the students. But he's definitely main developer. That's why I wanted to play his video, because he did main architecture by himself. I personally teach web programming, so I was guiding is it Heroku to deploy to, is it React to use on front end, is it MongoDB to use on back end, and student was doing main things by itself. So it's our future work to try different models and see how this behaves. Ideally, it's like a service. You deploy your model, and this bot, this AI bot, literally make it better for you. So probably it will be not free service. Eventually, we were thinking about patent for that, but we think it's very advanced, one of the most advanced lines of our research currently.
Yeah, my question was actually, so once this bot, so what is your strategy for trying to get more models from other persons to validate your this particular tool? So how do you plan to make people aware that there is this bot, and to have more models on which you can test whether the approach works really well in a more general context?
No, we are still in a playing stage of it. So obviously it's available online. So far, it's deployed to Heroku. But when we'll see how this goes. Not yet. We're at this stage of research, we're not yet planning that far.
Okay, so we are looking forward to whenever it becomes available to everyone. Okay, I think it's 15:40 now, so I guess we can go to the next presenter of today. So this is it's one of my colleagues in Belgium, actually, Christophe Ponsard from the CETIC Research Institute. So I don't know, Christophe, if you are there. Yes, yes, I'm hearing you. Okay, here are your slides. Okay, so you have 15 minutes to present your talk.
Okay, hello everybody. So yes, my talk is about a survey of automation practices in model-driven development and operation. As Tom mentioned, I'm also in Belgium from a research center, and this is a joint work with my colleague Valérie Ramon, with head of a department which is applying DevOps techniques and also model-driven techniques in the industry. So we were interested in putting everything together, and also from the perspective of this workshop to see how bots can really help in the automation, because, well, in DevOps, it's really the idea to automate, and using bots, it's really an interesting technology. So it's our first participation here, so we are still learning about bots. I was very happy to hear Stefan just reminding about the feature of a bot just before. Yeah, let me progress on my slide. So as I said, this is the context. So we are living in that infinite loop of the DevOps. Let me use my pointer maybe. With plan, code, build, test, release, deploy, operate, and all across those this development. If you take the model-driven perspective, well, let's say it can be model-based system engineering or software development. You have different models that can be used at different stage of this either development or operation process, like well, modeling really the system, then the deriving the architecture, using models of the different package for the building, then for the testing, different techniques, including model-driven. Then when you go into operation, you have models for the runtime configuration. And interesting also is the monitoring phase, when you try to gather data from the runtime and learn things that can help in the next iteration, in the next run of that loop. So of course, automation is critical, and there are many techniques, continuous integration development, which rely on service, not only on bots, and that was one of the difficulty at the start, to really understand the specificities of the bots. And my talk here was rather try to understand how those two fields can come together, and what's already there to build on top of that. So a quick reminder about the DevOps. Then I will look at different tasks, and especially what tasks are interesting for the bots. Then I will go into really the contribution, I believe, at this stage is the survey we did about 10 different case studies that were published, or that we carried out, and then some discussion. So if we look at the automation needs in model-driven approach, well, first in the development phase, well, I can start from that classical V shape of the development, where you see really the model. The model is central, the central part of driving the whole process. And of course, you will go from the requirements to design to coding by trying to build the model and refining them, deriving code from those models, and then in the other dimension here, you will try to validate as much as possible automatically, building test suite, maybe animating or simulating the system, and hopefully through that use of model, you expect some gains in the quality by detecting bugs earlier. So you have many tasks that are interesting, because you have to assess the model quality, build the traceability, which is really time consuming. So if bots can help in those checking all those links, or carrying some kind of impact assessment automatically behind the scene for you, it's really interesting. And then you have more verification and validation oriented tasks, including to an animation possibly. On the transformation side, you have different artifacts that have to be generated, document, for example, to support including certification, test suite, refining models across different layers, and of course also to generate the code. So bots can come into play in different parts of this this process. At the operation phase, there are two main parts. Well, one is more the monitoring. So different properties can be observed, checked to be sure that they really match the operation condition. For example, there we could generate monitors for that purpose. And also you can have runtime date reconfiguration, so more evolution, automatic form of evolution of your system. Using here again models that can be shared between the development and the operation phase, with different use case that can be functional but also non-functional, like for the cyber security, where you have to patch the system once you detect that you have been compromised and that you have some kind of evolution, or that some kind of patch that can be applied. There are of course many existing tools, so I took one here that is full of those commercial icons. You are probably familiar with across the whole life cycle. Those tools can run locally or in the cloud, so it can be integrated in various ways. What is important also that you have a communication layer that is important both for the human, because you have different kind of teams, different departments that need to communicate, but as also stressed, it can provide also an interface for the communication with bots. This is the same, but in the same figure than previously. So you have exactly the same steps, and you can see the different tools from the code to the build and deployment. I will not go into the detail of each tool, but most of those tools can also be controlled or scripted, or have some interface that make them available for interaction with bots, simply through those automation interfaces. And now going into really the core of the paper. So DevOps is heavily automated. Of course, everything is not a bot. So the definition, as stressed, is the notion of autonomy. That is, sorry, I pressed my mouse. This autonomous is very important. And of course, there is some kind of interaction with the human to at least have also some form of control and supervision, either directly or indirectly, maybe through those communication interface, or to some form of more general dashboard that can be controlled more in an asynchronous way. So if you look at the literature, you have different, you have this paper that states different roles bots can take in DevOps. I will not go into the detail, but at the planning phase, you can You can have user stories and continuous integration. You can have, well, those builds. So maybe it's not really a bot for this, but it was mentioned, continuous development to really perform those deployments. Rollback, if they detect some problem, they can automate some kind of rollback, provision also those environment, all the infrastructure, and then of course then also more reactive parts in the continuous monitoring and feedback in the operation phase. About our survey, so the methodology, as I said, it's not a systematic mapping survey, it's more an overview. So we went through our own experience because we have already some experience with model-driven and DevOps. We limited that, it's quite recent, so over the past 5 years. And we have a decent coverage of different domains from automotive, space, logistics, and this is just 10 cases. So we selected the most complete and compared them across different criteria. So just as an highlight of one of them, because I will not go through all of them, this is one from the railway sector. That was from Deutsche Bahn. You can see some numbers here, but you have already a number of artifacts, big system with many functions. And you can see here that the model is central, that you have a repository, but also configuration with templates, and then you generate a lot of different artifacts from them. Of course, the bots will help there, but interestingly, they are also used for other tasks, and one that I highlight here is a requirement bot that is used actually to update some knowledge about the way the requirements have been represented. So in that domain, they have patterns. Those patterns, of course, specified by humans, but the bots are there just to make the connection, maintain the connection between those patterns and what is actually really in the whole project base, so that when you discover new patterns, automatically they can be documented, and all the documentation, of course, can be updated. So it's interesting because then the human can really focus on the interesting part about identifying, validating those patterns, and bot can help in applying and also checking that they are effective. If we look here quickly at what we discovered from the survey, so you can see the different domains. We mentioned most of the time we have the companies, one or two are more fictional, but most are real case. What is most interesting to state is that about the focus, the automation, most of the bots are used in the dev phase, and most of the automation is there in the operation phase. There is not much at this stage. We noticed a number of things more at the analysis part, and for the traceability, actually, you can see here model quality, requirement bot traceability. Few of them more on test and code generation. It's not so frequent, so it's more on the development phase and analysis. And most of the language we can notice it's most of the time CSML language that was used. As you can see also, most of the time it's big companies that have been involved. So this might be a bias in our study actually right now, because maybe most of the time only big companies are publishing about that, or have the means to communicate, and so we might miss things that have been done by smaller companies. So, but quick discussion and discovery about the survey so far. So, first of all, about the collaboration part, as I said, it's most of the time in large organization, and most of the time also in specific department, because large organizations are somewhat divided, and they have most of the time problems to really deploy things at the company level. So so far it explains also why it's more in the design stage of the design department of the company that we can observe that, and at this stage there's not too much percolating widely in the company. So well, probably viewpoints and more channels are important to do that, and could also be interesting to deploy bots for that. And interesting use of bots could be the use of virtual assistant for helping in the modeling, and also providing continuous feedback on the model quality. Another point is for the transition between the dev and op phases, so from one way or the other way. So as I said, from dev to ops, it's more the virtual environment that could be interesting, and possibly use kind of digital twin here that can be also put in interaction with bots. In the other direction, back from the operation back to development, there are also many interesting opportunities based on this monitoring process. We feel here that probably more descriptive language could be interesting. Of course, this really needs that the whole chain is model aware, which is not always the case. And then the bots can really try to learn things from that runtime data, and put that information back into design models as form of parameters, or maybe learning some models. For example, to carry out modernization. It's one of our use cases right now. It can be an interesting process. And then also have things that are more incremental. It's really also interesting to accelerate those iteration, well, either functional or also for non-functional requirement like security, and also in a certification context that can also bring value, because it's usually heavy process, and the bots can be very valuable to provide all the consistency check and the rebuilding of the standard documents that are involved there. Well, this is my conclusion now. So, well, as I told you, it's a very general survey right now. We discovered some interesting things, but most of this is a doorstep for a more systematic study. For the support of bots in model-driven, and also to cross-check with another survey that has been published recently, but which is more about the use of bots in the software engineering in general. So those are all two tasks on our research agenda right now. So that's all for me. And if you have questions, sorry.
Okay, thank you, Christophe. As usual, except for me, I don't see any questions on the chat. So one of the questions I actually had is that, okay, if you take not specifically for model-driven development, but in general for DevOps, so there is lots of ways in which you can automate support for DevOps. So you have like CI/CD services that can either be like self-hosted services or through the cloud. It could be done through bots. It could be done through GitHub Actions or something else. So there's different ways in which you can automate all of this and support all of this. My question was more of a generic nature, in the sense, okay, given that you have all of these different tools that can help you to automate DevOps in general, which of these different approaches should you use in which particular context? So, because your focus was mostly on bots, but like if you take today, for example, the GitHub Actions that are becoming much more popular, they seem to be, at least for some things, replacing bots. For others, they don't. So when should you use which particular approach for automating DevOps practices?
Mm-hmm. Yeah, as you said, it's well, it's a toolbox when different different service or bots, or as you said, GitHub Actions now. I think, well, the things that are more static and that are that can well be built in the standard pipeline. Well, you can use that as service. I think the value of bots is in the flexibility they provide. So the ease of implementing them, interacting with them, tuning them from my point of view, and they can bring the additional glue on top of that static pipeline. They can really provide the glue and all the flexibility that can help you in improving the productivity and going faster through the pipeline, fixing things that might have been broken and things like that. So I really see at a combination, and of course, this is the generic answer, but the specific answer will depend on the project, maybe on the technology. If it's easy to fix and develop a GitHub action for something, then it can be done that way. And as you said, maybe it will replace some different kinds of bots. But it's just, well, the general objective that is important to achieve. It's really to have this quality, this flexibility and performance in carrying out those cycles.
Okay. Okay, I had maybe one more small question before we go to the keynote presentation. So the question was actually, okay, so yours talks specifically about the use of bots in the context of model-driven development, DevOps for model-driven development. To which extent are these, because there's already also quite a lot of bots available that you can use in traditional development. If you would compare this, and if you would see the bots that are used for supporting DevOps for traditional development and compare them to those that could be used for model-driven development, what would be the most distinguishing characteristics?
Well, in traditional development, there are already a number of models. That's one point. So maybe we are already, everybody's doing model-driven development without knowing it. But for more advanced model, of course, there are more advanced bots, I would say, probably. And probably also for those use case, system engineering use case, when you have many refinement level, it's more important to have models at more abstract at a system level and for components and subcomponents and linking everything together. It's really hard to do it manually. So I think for those kind of system, you have something that is a bit different. But it's maybe then it's not only software engineering. Then it's more so system engineering. So it's the context is a bit wider. So I had some problems. So when writing the paper, sometimes I was focusing. Am I really at software engineering? Sometimes it's more actually system engineering. Actually.
Mm-hmm. Okay, thank you. So
thank you.
It's time to go to the invited keynote speaker, who is Peggy Storey. So I don't know if I actually need to introduce her. By the way, Peggy, if you're there, feel free to already share your slide so that we can see if it works on Zoom. So Peggy Storey, she is a professor in computer science in Victoria University, University of Victoria, if I am correct. She has been doing a lot of research in the context of human and social aspects of software engineering, and her keynote that looks really interesting to me would be about the use of software bots as superheroes in the space of developer productivity. Peggy, are you there? And can you share your slides?
I am here. Can you hear me
yes.
okay?
Yes.
Okay, I'm just trying to share my slides.
Okay, great.
There we go. I think that's all good.
Okay, so you will have like a 45 minutes of presentation followed by up to 15 minutes of questions.
All right. Let me just see where my screen has actually gone here. There it is. All right. I see some familiar faces. Fantastic. Thank you. And thank you for having your cameras on too. It's lovely to see people, to see faces. I think it's afternoon there. It's early in the morning for me. I'm sorry, I'm just joining the workshop. It was Mother's Day here yesterday, so I had a lot of family over last night, so a bit of a late night. So welcome today. I hope the workshop's been going well so far. First of all, I want to thank, I guess, Mariatta and the other organizers for the invitation to give this talk. I haven't actually been doing a lot of research with bots in the last few years, so I hesitated to say yes. And then I thought, wow, it's a good excuse for me to get caught up and to see what everybody's doing. And then maybe to have a little bit of fun with this talk and introduce some new ideas. So this is a collaborative talk. I want you folks to maybe help me brainstorm a little bit. You can use the chat. And you can even interrupt me, I think. And Tom, if I'm going over time, just let me know if I do get interrupted.
Okay, I will.
Yeah, so as I mentioned, I've been outside bots for a while. So this was actually a little bit of a trip down memory lane for me because I went back over the research that I did before, but at the same time, I got caught up with all of the cool stuff that's been happening in recent years. So, and in particular, the archive that's on the BotSE webpage was fantastic. Thank you for that. But so what I thought I'd do is I just start off with a quick kind of review of some of the thoughts that we had about bots a few years ago when we first started looking at them, and a review of the related research. And then I'm going to pivot a little bit and talk about thinking about, well, what could bots do for us? So looking outside what they do today and looking for the future. And for that, I'm going to look at the space of productivity. It's a framework for defining developer productivity. And I also want to look at how bots could be charged up with superpowers, if you like, to empower developers so that they are more productive. And that's kind of the fun part for this talk today. So hopefully you'll help me out with that. So going back to the research that I did in 2016, along with Alexei Zagelsky and my student Carly LeBoeuf, bots weren't being studied at that point in research. They were being used in industry, and actually Alexei was the one who kind of alerted me to this. And I started looking at how bots were being used in industry, looking at blog posts and so on. And we found quite a few bots were being used in industry. So code bots, we found them being used for developing code, for writing code, for testing, DevOps bots, support bots, documentation bots, and entertainment bots. They were pretty much all over certain companies that we were looking at. And one of the themes that we found was that collaboration, of course, was a theme that cross-cut all of them. And so that was pretty cool. And let's see, my slides don't want to advance here. And what we were also doing when we looked through all of these bots, that was, you know, what was it about them that kind of made them the way that they were? And so we looked at all of these and we defined what are the main characteristics of these bots and how could we define them? And so we came up with this set of questions. What do they do? How autonomous are they? How intelligent? How do you interact with them as a developer or as a user? Where do they live? So what environment are they, you know, in? Where are we going to find them? Is it GitHub or is it somewhere else? And then how are they created? In what ways can they be created by developers? And some of our early sort of insights, we came up and I proposed this early productivity framework that I'd actually forgotten about until I started looking at this today, a couple of days ago. And the framework that we came for the bots was to think about them in terms of efficiency and effectiveness. So efficiency, bots helped us do things that are faster, so they helped us automate repetitive tasks, and they help developers stay in flow. And then on the other hand, you could look at them in terms of how effective were they? So what were they helping you work towards? Were they helping you improve your decision-making? Were they helping you support your cognition as part of a team? Or were they supporting how you regulate your work, or how you regulate the work with others, or how you regulate work, you know, across a company? And Alexei also had this really cool slide that he put in one of his talks in 2017, which were the research opportunities that he saw. And I think this is still a really cool slide in terms of identifying certain ways that we can do research. So on the one hand, from psychology and CSCW, we can do some research to look at, are these bots, should they be treated really as virtual team members or as tools? How do we treat them? And in terms of software engineering and organizational behavior, what roles or activities should they be used for? But where shouldn't they be used? So are there some boundaries there? And another question in CSCW is, how autonomous should the bots be? And how does that fit with task ownership? And then he also had questions that looked at formal verification synthesis and machine learning and automatic reasoning. Is it possible to automate some really critically relevant abilities that humans rely on? And other points here, how to integrate bots into a team, how to improve their effectiveness and productivity, which is the focus today, and how to make them more effective and enjoyable, so improve their user interface. Then Carly, my master's student, she's now working at Microsoft. She took on this as her master's project. And you can look at her thesis. By the way, I have all the references to everything at the end of my talk, and I'll share my slides. She did a huge amount of research trying to understand this very, very rich space of bots. And she saw that software bots, or she defined software bots as the interfaces that connect users with software services that provide additional value to the user. And I loved this definition that she came up with. So the bot is here in the middle, and the integrated services are over here. They're potentially internal to the bot, but there are also potentially external services that can be accessed through APIs, and the bot gives that interface to the user. And she noted that bots add additional value, right? So it's not just that it gives an interface to the basic capabilities in the service. So they're different from non-bot scripts and programs because they bring additional value on top of those. And that additional value can be in the form of automation, or potentially consolidating multiple services, or through some fancy interaction mechanisms, or by giving some kind of persona. So anthropomorphism through the bot. And she also distinguished between chatbots and agents. So for her, software bots encompassed both chatbots and agents. And the difference here is that chatbots are bots with natural language capabilities, as opposed to agents that can sense and act upon their environments. And they are also intelligent, autonomous, and social, but they don't have these natural language capabilities. And some people have disagreed with this definition here, but I quite like it. She convinced me that this was a good way to think about bots. Another contribution from her thesis was coming up with this taxonomy of software bots. And I have, as I said, links to the end. Actually, her thesis was published in 2018. And she had this very rich taxonomy with with 3 different dimensions. So the 3 different dimensions are the environment, the intrinsic, and the interaction. So from the environment, that's where the bots live, where you're going to find them. The intrinsic dimension are these facets to do with what is it intrinsically to the bot. So what knowledge do they have? What reasoning capabilities do they have? How do they adapt? What goals? How do they delegate? And then the interaction dimension is how they interact with external services, or how they interact with the user. So how do you access them? How do they sense externally? How do they communicate? What kind of initiative do they have, and robustness, and so on. And each of these dimensions has, as I mentioned, a number of facets. So these are the 3 dimensions. And then each of them have a number of facets. And then also some of them have subfacets, and then values for these different facets. So for example, with scope in the environment, is it bounded or is it unbounded in that environment? Or predictability, is it stochastic, uncertain, or deterministic? And I remember when she came up with this framework saying, oh my gosh, there's just so many facets and subfacets and values here. Can we simplify it? And she was like, nope, we can't simplify it. We need all of this because these are all really important characteristics that we need to think about in terms of bots. And she really convinced me of that at the end. It's a very, very rich framework. And around the same time, Pekary and Vanderhoek also came up with a framework. And their framework, I think it also had in another paper, they talked about intention, but their main characteristics were type, the direction, the guidance it gives, the predictability, the interaction style, and then the communication channel that the bots use. And I love this framework as well. It's a little different from Carly's. It's a bit more simple and it's easier to maybe look at a bot through this framework. But I love what they pulled out. Actually, all of these also appear in Carly's framework. But these are sort of the salient things and maybe maybe a slightly easier way to look at bots when you're trying to compare them. Then I found actually just a few days ago, the paper by Santhanam et al. I think I saw Stefan Wagner on the call today. He's one of the co-authors, where they did a systematic literature review. So it's pretty hot off the press, I guess, at PeerJ 2022. And one of the things that they, noticed is that, yeah, bots kind of started being talked about in 2016. And I think their review covered up to 2020. And we see in 2020 that there are 41 papers. I guess there's more in 2022. I don't know if anybody has updated this and looked at this for 2022, but certainly it's still a rich area of research. I loved the framework in this paper. I don't know if you haven't seen this paper, go read this paper. This is a beautiful framework and it pulls out three, I guess, main characteristics. So the applications where the bots are used. So what are they being used for? Are they being used to manage software repositories or improve software repositories in some way? Are they bots for doing Q&A? Are they bots for interacting in the software development environment? And then the modes of interaction are the chat bots or bots in communication or voice assisted bots. And then these design principles, so the bot persona and some principles that they saw in the paper, such as nudge theory and HCI and being flexible and so on. And then I took a look at the repository, the archive that you have, which is very, very rich, by the way. Thank you for that. I guess that's Imad and colleagues and Abdel Talif and Badram. Thank you for that. And I took a look through this and wanted to try to kind of wrap my head around what are the bots that are, the bot papers. And what I found was I classified them. I did this pretty quickly just by reading the abstract, is that 49 of these 102 papers are mostly about solutions. So descriptions of bots, ideas for bots. 21 give us some very rich design knowledge about how to go about designing bots or what the interaction should be like. And then 10 were literature reviews or frameworks. And 7, I think you just had a session on this, on bot detection. This is a new topic. It wasn't around back in 2016, 2018 when we were doing the bulk of our research in this. But there's now a lot of research in trying to understand, well, where are the bots? Like, is it a human or is it a bot? And then there were a few that were mostly focused around empirical studies of bots. Of course, some of these papers also had empirical studies of them. Some of the papers in the repository were not about software development, though, I thought. So I was a bit kind of confused about that. I have a spreadsheet. If anybody's interested, I'll share it with you. It's kind of messy, but I'm happy to share it. And so there's assumed premise that bots will boost developer productivity, right? And, I had this premise back in 2016 as well. And it would seem that, yes, they do, right? Anybody disagree that they don't boost productivity? They do, right? They help developers, right? They help teams of developers. But can we do better? Or are we kind of done, right? Are we reaching a plateau? Or can we do some really cool, fun new stuff with bots? So that's what the rest of this talk is about two themes to charge up our design juices a little bit about bots and see what can we do? How can we brainstorm about designing some more exciting, potentially bots that we hadn't thought of before? I'm not saying the current bots aren't exciting. They're very exciting. I'm just saying, looking to the future, let's think about some new ideas. So for that, I'm going to use the frame of design thinking. I'm not sure if anybody's familiar with that. I have a link at the end. So design thinking is a way of designing new ideas and new tools to help users. And it starts with empathizing, defining the goals. After you've empathized with your users, then looking for ideas for something outside of what you would normally look at. So you get ideas from maybe picking books out of, or words out of a dictionary, random words or random objects in the room, and you try to use them to come up with new ideas. Then you prototype, and then you test. I'm going to focus in the next few minutes on empathizing and defining some user goals and some ideas. And that's where the ideas are going to come from, the superpowers. And empathizing is looking at this space of developer framework that I've mentioned, developer productivity framework. So recall my earlier productivity framework back in 2016 had 2 dimensions, efficiency and effectiveness. So efficiency, do things faster, keep users in flow, automate tasks, or being effective, work towards more meaningful goals. Well, since then, I've been working with a lot of colleagues in the space of developer productivity, and we've done a lot of studies on trying to understand developer productivity, particularly during the pandemic. There was a bunch of us trying to understand what happens when developers work from home. Are they being as productive? How are they working with their team? And we had a lot of different findings from a lot of different kinds of studies that we did, and it was hard to make sense of them. And so we came up with this framework called SPACE to basically frame our results around developer productivity. And the reason we did this is that we were noticing that a lot of folks, particularly in industry, tended to focus on just looking at one aspect of productivity. So they were measuring, the number of pull requests, or the number of commits, or the number of code reviews, and saying that, oh, look, our productivity has gone up over the pandemic because those numbers were going up, without taking into consideration all of the other aspects of productivity that might matter. So let's take a closer look at each of the 5 dimensions in SPACE. So the first dimension, or dimension in SPACE, is satisfaction and well-being. So I did some earlier research as well that showed that developers that are more satisfied tend to feel more productive, and developers that feel more productive also are more satisfied. And we've seen this also in other research on developer happiness. Happier developers tend to be more productive. So satisfaction and well-being is an important dimension of developer productivity. And it refers to how fulfilled the developers feel with their work, with their team, with their tools, and with their culture, and just how happy they are with their work in general, and also their growth. So how they're learning about new things affects their satisfaction and well-being. The second dimension is performance or outcomes. So this is, how much code are we delivering to our customers? How many new features? And is it of high quality? And it turns out performance seems like it's something that you should be able to measure pretty easily, but it's actually quite complicated, because which measures do you actually care about? Do you care about features, or do you care about how many users are using them, or how useful they're finding those features? Then the third dimension is the one that a lot of people perhaps naively think about developer productivity, which is about activity or the outputs. So this is, of course, an important metric to look at. It's an important signal, how much code is being written, how many pull requests are being made, but it's not the only one, right? And so there are other things like attending meetings and helping other developers onboard to projects are also important activities, right, that we should consider. Then the fourth dimension in SPACE is communication and collaboration. So this dimension emphasizes that software development is a team activity, and it's inherently a creative and a collaborative process. So when we think about developer productivity, we can't just think of them alone. We have to think of them as part of a team and the activities that they're doing and how they're helping others. And then the last dimension is efficiency and flow. So this captures the importance of flow and being in that state of flow for individual developers, and the negative impact that interruptions can have. I just saw the chat and then I was like, oh yeah, I'm being interrupted. No, I'm not. I love the chat. Keep it coming. I'll try to refer to it. And when you think of efficiency and flow, it's easy to think about this in terms of the individual developers, but we also think of it in terms of the team. So how efficient is the team working together, and how is the team making continuous progress. So those are the 5 dimensions, okay, of developer productivity. And in another study, we asked managers and developers, we didn't show them space, we just asked them to define productivity. And what we found was some misalignment. And I bring it out here because when we're designing bots, we might want to be thinking about improving developer productivity across all of these dimensions, not just according to one. So interestingly, just a little side note here, managers were more likely to think about productivity in terms of performance outcomes, so the quality of the code or features delivered, and developers were more likely to think about it in terms of activity. So the numbers of lines, the pull requests, you know, the things reviewed. And then the other dimensions had some kind of, you know, coverage as well by both groups. But you'll see that satisfaction and well-being, a few people did think about it, but not everybody. So what if we were to look at bots? So this is where I need your help, okay? What if we were to look at bots through the space framework? How would we characterize them? Into which of these you know, sort of dimensions would we put our bots that we see out there? So I made an attempt, but I'm open to be corrected. So for satisfaction, onboarding newcomers and nudging behaviors, I think are some of the roles or tasks that bots have been doing. So I'm looking at what we have today, not what we could do. And so I found some examples in the SE, the BotSE paper archive. And so onboarding bot and mentor bot were 2 bots that help onboard newcomers to projects. And this not only makes the newcomers feel happier in their work, but it actually makes the people who help them happier as well and feel more satisfied with their work. And I also found NudgeBot, which is nudging behaviors. So, you know, we often, you know, procrastinate and don't do the things that we know we should do. But if we do get nudged and we do them, we feel better afterwards. So that's why I put them in this dimension. In terms of performance, I put, and you might disagree, defect prediction, static analysis bots, and testing bots, and program repair bot in here, because these bots somehow improve the quality, okay, of the bots that are there. And so these bots, defect prediction, I found JIP-bot, and then CC-bot and spec-bot for static analysis and testing. And then there are all the repair bots, Repairinator, RHero. I might have put these in the wrong line, but generally speaking, those are bots that fit into this category. Somebody asked, are there studies showing how space relates to the DORA framework? Oh, this is a great question. Maybe I'll come back to this at the end. Well, I can answer it now. So actually, you know what? I'll answer it in a few minutes because I'm going to talk about something that relates to this. So thanks for the question, Bianca. And then for activity, I put these bots here. So the bots that take our natural language and put them out in code. Is Copilot a bot? I don't know. It's not a chat bot, but it's a bot, I guess. Bots that refactor code, bots that do pull request management, and documentation bot. Then under collaboration, I found some bots that I thought supported collaboration and communication in some way. So there's retrospective bot that helps a team do retrospectives about their agile processes. Then there are a number of bots that find experts or find code reviewers, such as Mention Bot or Expert Finder. And then there are some bots that do collaborative modeling, such as Socio and Domo Bot. And then bots for coordination, such as TaskBot and Semi. And I struggled a little bit with Q&A and information sharing, whether I should put it in here, because many of these bots don't really enhance collaboration, but they reduce the need for it. But maybe that makes the collaboration that does happen higher quality. So I put those in here. Maybe you disagree. And then the last one is task automation and breaking changes in dependency management bots that I put under efficiency and flow, because these help either the developer or the team of developers work more efficiently and not get interrupted by things, so that they can stay in that state of flow. And we have, can we fit StaleBot in here? Oh, absolutely. Yes. Oh, in efficiency. Yes. StaleBot could go in there. It's a really good point. All right. So let's go back to space and also that question about DORA. So what is it, or who is it we're aiming to improve and support through thinking about these different dimensions? So for this, I'm just kind of lifting it up a little bit, I guess, one more level. And we can think about, there are 3 core things that we want to improve. The first one is the experience of the developer. So thinking about improving how the developer feels overall. So this isn't just about their satisfaction, but it also refers to the state of flow that they might have and how efficient they can be, as well as how they communicate and collaborate with others. Then the next thing is that we might want to think about improving the quality of the product. So improving, removing bugs or improving its performance. These I put under product quality, which relates more to performance outcomes. And then engineering velocity is looking at the speed. So this is what DORA measures. The DORA metrics measure engineering velocity. And so this is looking a lot at activity and output all the way through to deployment. So I guess it also interacts a little bit with performance. So these don't map one-to-one to these dimensions. These are sort of on the outside, and we can look at these 5 dimensions to measure product quality or engineering velocity or developer experience. And I pull these out because I think it's important to remember what it is that we're trying to improve and support. Are we trying to make the developer happier? Are we trying to focus on the quality? Are we trying to improve the velocity? And by the way, anytime you do any of these, you're going to have a positive, potentially, or negative effect on the others. So if you help developers, push their code faster and deploy it faster, then that's probably going to improve their experience. Not necessarily, though, right? They might be actually getting bored by writing code faster. So bots, of course, already help. And I showed that through the space framework and mapping them to the different dimensions. But I want to look at it a little bit through now these lenses of the developer, the product quality, and engineering velocity. So in terms of the developer experience, we have bots that reduce cognitive load, that help them with their self-regulation of their tasks, nudge them towards behaviors that probably makes them feel better. And then we have bots that improve their efficiency and flow and help them stay in that state of flow. So automate boring tasks or reduce their interruptions. And then we have a bunch of bots that enhance collaboration and coordination and connect people with each other and help them distribute their cognition. So the Q&A bots, in a way, are distributing our cognition across, these different resources and then helping, give that information to the right person at the right time. Then looking at the product quality, we have a lot of bots. We saw Repairinator, for example, that improve the quality of the code and the design. And then in terms of speeding up the velocity of the engineering process, we have quite a few bots that help and do that to actually increase the velocity of the process that we're using and getting our code through the system. Yeah, and so a question, improving supporting end user experience would be another thing where bot support could help. Absolutely, great idea. So can bots help more? So let me go back to the design thinking, the 5-stage process that I talked about. And let's start with thinking about empathizing with our users and defining some goals. So we've already seen that many of the bots already empathize with our users and provide much support for our users. But let's think about maybe what we're not doing that we could do better. And for this, I'm referring to Mariatta and her co-author's paper, Wessel et al. At CSCW. She pulled out quite a few ways that bots could be improved. And I'm also referring to a paper that I just co-authored with my colleagues, Michaela Greiler and Abhi Noda, where we looked at developer experience. And from that research, we interviewed a lot of developers and we found what are the factors that influence their experience and what barriers do they face to having a positive experience. And so I'm pulling some of the themes out of these 2 papers to brainstorm about other ways that we could empower developers along the 5 dimensions of space. And I'm sure that you probably have other ideas. So one way is for developer satisfaction. If you haven't seen the work by Kat Hicks, Dr. Kat Hicks, I recommend you look at it. She has looked a lot at how learning and feeling competent is really important to developers and having time to do that. This is also something that's from the self-determination theory, that feeling competent and actually having an autonomy are two very important things for feeling fulfilled. In Marielle's paper, she talks about the need for bots to support newcomers, and we're seeing some, but I think we need a lot more. And well-being, work-life balance, can bots help developers balance that a little bit more? We're seeing bots being used to enhance work-life balance in other areas, but can we bring more of that into development? And could bots help with developers feeling like they have more autonomy, or maybe asking for more autonomy in their projects? And in terms of satisfaction, we have an idea here. Support from mentors, not only for newcomers. Yes, definitely. And by the way, when mentors have support for doing that, they will then feel more satisfied as well. Under performance, I pulled out a few here. Marielle noticed time estimates are needed. And in our research, we found that having clear goals, knowing what the scope of your work is, having clearer priorities, having a say on priorities, having a roadmap are really important to developer experience. How could bots help with that? Could they somehow pull them out and share them with everybody in the team, or allow people to say, we don't have clear priorities. I don't feel that there's a good roadmap here. Another one is feedback on impact. Could we have bots that help, give more feedback on the impact that developers are having? Developers feel happier when they know their work has impact. Under activity, I'm not going to put a lot here because I think we focus a lot on this already, but a couple of things that came from Marielle's paper was better code review, smarter bots. We still need smarter bots. Okay, maybe some of these superpowers can help us here. Then under collaboration, some of the things that came out of our research is the importance of relatedness. And actually that comes from self-determination theory as well, that feeling connected with others is really important. Can bots somehow boost that and amplify those connections? Can bots help with psychological safety and detect? I think we have some bots coming in this space already that are detecting emotion. I know Alexander is on the call and he's been looking a lot at this. What about bots that help amplify recognition from others when you do good work? And bots to even do a better job at knowledge sharing. This is still a challenge. And then under efficiency, we still need more with balancing interruptions. Marielle noticed in her research that notifications are still a problem. I think they'll always be a problem, but we could do more with bots here. Interrupt, the work that's looking at developer flow and having bots manage that. We're starting to see some research in that space already, and having better UX and, healthy code base. So when developers remove technical debt from the code, that allows developers to feel more efficient and feel flow. Right, going back. So that was thinking about, can we use the space framework and some of our research that we've done to think of new ways of empathizing with the developers and helping us define new goals. But let's look at this next one here, ideate. So this is the idea that you go outside of your domain and you get ideas from outside of your domain and see what can you pull in. And then the idea is being used again here, is that you could look at, the dimensions of space, and you could look at these superpowers and put them together and see, oh, do we have new ideas for bots? So a brainstorm with superpowers. And this part of my talk is inspired by a paper by Willett et al. I really recommend you read it. So they looked at how superpowers could be added to information visualization tools to amplify what those tools do as well. So first, in terms of superhero, one of the important things about superheroes is that they are personas. And actually in the Santhanam et al. Systematic literature review, one of the design principles that they pulled out was having personas. And we see personas being used already in many of the bots. And we see superhero. Hercules was one bot. I don't know if it's still around. but it is, you know, a superhero bot. So it's important to think about these superhero personas, and can we get ideas from other superheroes to help us design new bots with new powers that will help empower developers. In terms of the types of superpowers, there are two main types of superpowers. So there's epistemic superpowers, so how characters gain knowledge about things, people, or phenomena. And then there are pragmatic superpowers, and there's two different types here. So physical, how characters actively manipulate things, people, or phenomena, or mental, how characters influence others' thoughts, ideas, and emotions. Okay, so there's a sort of a high-level framework of the different types of superpowers that we can maybe think about. And there's lots of different abilities that these superpowers come with. So I just pulled out a whole bunch of them here. So immortality, we don't have a problem with that with our bots, right? They can live forever. But time manipulation, is there something we can do with time manipulation? Omnipresence is the idea that, you know, the superhero is everywhere at all times. Well, we can do that with bots, right? We can clone them. Omniscience is the fact that they know everything. Enhanced senses, their ability to heal, to have empathy, to project knowledge from one person to another, or from them to another. Enhanced cognitive speed, enhanced intelligence, enhanced recall, enhanced memory, enhanced comparison, clairvoyant, and precondition. These are all superpower abilities that we see in the superheroes in our culture. Technology manipulation. Well, okay, our bots are already doing this. Tool proficiency. So maybe maybe we can think about bots that are proficient in using a tool and helping users use that tool. I think we're already starting to see some along this way. Multilingual. This is a problem, right? A bot that helps different users in different parts of the world, or, you know, convert comments, right, in a Slack channel. Making the invisible visible. So a lot of the challenges in software development is that a lot of our work is invisible. Helping others, for example, is invisible often, but can bots help us make that visible? Or being invisible, you know, helping me be invisible when I want to be invisible as a developer, perhaps, and granting wishes. Patience, love it. Yes, love it. And self-healing bots, yeah. So I also found this other paper on, or not paper, actually, it's a blog post on superheroes that can inspire self-development. I've got a link to it down there. And they talk about 3 different realms. So the mental realm, the physical realm, and the spiritual realm. So the mental realm is, you know, about your personal character, your values, and your principles. And the physical realm is your career, your material success, and your health. And then the spiritual realm is life meaning and fulfillment, which is something that developers really care about, is having meaning in their work and doing meaningful work. So can we get inspiration from these kinds of characteristics that superheroes have to inspire and to improve self-development of developers? And this post, I just pulled out some of the images and some of the characteristics that these superheroes have that relate to self-development. So for example, you know, having courage, you know, to do the right thing, or to speak up, or to, you know, take on a brand new feature, for example. One of the characteristics is focus and concentration, right, which relates to efficiency and flow. The importance of retaining humanity. So being human as humans in our development process, but also having bots perhaps that retain some of that humanity as well. Some of them harnessing technology, truthfulness, and love. Okay, I love this one, right? You know, can we have a bot that brings more truthfulness, right, into our development and into our work, and that has love for everybody and helps us, you know, have that more in our projects. Imagination, vision, kindness and humility, intercultural skills, and resilience. We could all use more resilience. And weakness compensation, right? We all have, you know, weaknesses that we have to deal with and compensate for. So designing superpower bots to empower developers. Can we do this? Can we take some of all of these characteristics that I just talked about, and can we take them and empower developers in some way? So I added some of these ideas. So I went back to the needs that I found in Greiler's work and also in Wessel's work. And I just put some ideas here. Can we take some of these superpower ideas and can we apply them to some of these needs and come up with some new kind of bots that we haven't thought of before? So in terms of satisfaction, looking more at truthfulness and love, kindness and humility, and retaining our humanity. Maybe these are some of the superpower abilities that we can add here. Convincing others, a bot to help us convince others, like often a problem that developers face in their projects is that they don't have data to show that there is a problem in their project. So if you can somehow, have a bot that shows, yes, there is a problem. We have stickiness in our tools, or we have friction in our tools, or friction in our team, then maybe, bringing that data out can help you then convince others. Having courage to do bold new things, having a vision, using imagination. The bot could maybe help us use our imagination and encourage us more. Of course, enhanced intelligence and cognitive speed for doing activity. I think we're already doing a great job, perhaps on this line, so I don't go on about this one a lot. And then in terms of collaboration, clairvoyance, truthfulness, again, making the invisible visible, and intercultural skills are more abilities that we can think of adding to our bots. And then finally, for efficiency and flow, focus, concentration, precognition. So having bots that allow us to, tell us that, oh, you're working on code that somebody else is working on, right? We have some tools like that in software engineering. And you said 45 minutes, so I'm at 7:46. I'll stop there and leave some time for discussion. So the main takeaways that I wanted to share is that, first of all, productivity. A lot of the time when we design bots, you'll see at the beginning of the paper that they'll talk about improving developer productivity. And I just want you to think about that, or all of us to remember that productivity is more complex than we might think. It involves all of the 5 dimensions of space, and that our bots should be designed to empower developers, that this could be something we could think about, not just replace them. And let's have fun doing it, right? Let's, think about some other ideas, maybe some of these superpowers can drive novel ideas for bots in along the space of productivity. And with that, I'm finished my talk. Thank you very much. And I haven't done a good job of keeping up with the chat, so I'll go and have a look here.
Okay.
Yeah, thank you,
Peggy, for a great talk. Okay, it will be, I guess there will be clearly questions from the audience. I also have not been able to keep up from the chat, so I propose that if someone wants to intervene and ask a question, to just raise your hand or just open your microphone and ask a question.
I have a question.
Yes.
Back when I started computer science in my associates, I was a physics major at the time, and one of my friends, we were having into mental health, and we wanted to invent a therapy bot, but we only got as far because we were an associate, so we didn't learn machine language, machine learning, we didn't learn NLTK, and I still carry that, that repository in my GitHub, where I kept the foundation for that therapy bot. And I was hearing your talk, and how do you actually therapy bots, going forward to the consumer, like how do you, is there like a reasoning that would is there like an institution that would borderline govern that area of making therapy bots? Because it's like a superpower, at the end of the day, somebody's gonna have to tell you, you're making something that interacts with a person and an individual, and you kind of are helping them change their emotions and doing cognitive behavioral therapy or any type of therapy that you can be doing. And I just have experience in this because I like psychologists, and I do like therapists and social work. So I did find it very interesting that you mentioned that in your little earlier tad bit. So are there institutions that govern these type of bots that get created, or are they just, mostly for research at the moment?
So outside of software development, there are a lot of bots and a lot of apps for therapy and mental health and improving mental health, and also cognitive behavioral therapy, whether they're under any kind of body that makes sure that things are done safely and privacy and all of those issues. Some of them will be, some of them will not be. That's a really good point. But I think there's a lot that we could learn from those other areas, and maybe it's a great idea, maybe bring it into software development. I think burnout is a big thing that everybody's realizing is a problem, right, to be addressed in the industry and in our education environment as well. I've never before seen so many students burn out as I have this last term. That maybe I think it's a great idea having bots that maybe detect that, or remind you. In fact, there are bots that, and maybe I read it in this archive, now I'm getting confused if I read it here or read it somewhere else, but there certainly are tools that are being used to remind people to take a break, and to not read their email when they're, during work, because that, makes you feel more stressed and interrupted and so on. So there's tons and tons of stuff out there. I think it's a great idea to go and look at some of that and bring it into software development, and to bring it into a team, not just an individual, but maybe it would be more successful to bring it into a team and have everybody on the team use it, and have some awareness that we're all using this thing, and if I'm not available, this is why. So it's one thing to say that I'm going to turn off my interruptions, but if your team members don't appreciate why you're turning your interruptions off, for example, or your notifications off, then you're going to end up feeling more stressed, right? So it's a great point, a great comment. Thank you.
Okay, Walid raised his hand, so please go ahead.
Hey, Walid.
Hi, Peggy. Good to see you. Thank you very
Yes.
much for the talk. As usual, very informative, very insightful. Thank you so much. I have actually a lot of questions. I just will pick one. I guess it's perhaps the most controversial. I hope you don't mind.
No, bring it on.
It's actually related to the last part of your talk. So I was wondering, some people might argue software developers and maybe techies in general are not the strongest people when it comes to maybe soft skills, social skills, maybe emotional intelligence, and so on. So are we making it even better to outsource these skills to bots?
Yeah, it's a great question. Really, I love it. I love that question. We need to be careful there, right? Definitely careful, and it relates to the last question really as well by Jose. Like what are we doing here, right? If we think that we're helping people and we're actually not, we're undermining them, and maybe bringing other power structures into the community. I mean, it's definitely, we have to be very, very careful at any time we bring interventions in like this. But I will say that, being aware that there are these risks is better than not being aware. And, bots can maybe bring some awareness that there are these things, but like any technology, there's a social side to it that can't be ignored. And anytime you bring benefits, you can bring risks and challenges. So yeah, really, really good point. I thought the question that you were going to ask is, developers, they don't have a lot of social skills, and a lot of these superpowers are kind of geeky as well. And, like maybe we just bring more geekiness in. And that was why I kind of looked for, the bots, or not the bots, the superpowers that are more, about self-development and, brought these other kind of skills in as well. But yeah, I mean, I'm not saying we should superpower our bots. I was just trying to bring something that was fun to say, let's have a little bit of fun with designing our bots, but be anchored in what our needs are, right? Not just have these cool ideas, but be anchored in and empathize with our users and understand our users, and then look for new ideas that could empower them, right? But yeah, anytime you have any technology to empower people, you introduce a risk for sure. Thank you for bringing that point out. Really appreciate it.
Anyone else having questions?
There was some earlier. Yeah, this is related to the kindness in programming for sure. Yeah. I'm really looking forward to that paper presentation.
So I had a question which is actually related to, so suppose I have a bot and I want to basically measure or analyze to which extent a bot improves upon productivity. Now you mentioned that there's like these 5 different dimensions, the space dimensions of productivity. Is it actually feasible, possible to objectively measure whether a bot is actually improving or decreasing upon each of these dimensions? For some, it seems almost impossible to do it. For others, it seems more or less feasible. What's your opinion on this?
Such a great question. I didn't even pay you to ask me this. These questions have been fantastic. Yeah, really, really great question. No, it is not possible to objectively measure all of these dimensions. But that doesn't mean they're not important. There are subjective measures. So you can ask developers, you know, how are they feeling? What is their well-being? How's, you know, psychological safety, you know, how is that in a team? Do they have periods of flow? Actually, maybe you can objectively measure periods of flow, but for a lot of you know, certainly under satisfaction and collaboration, very hard to objectively measure. And in fact, in our paper on space, we talk about the importance that if you are going to measure productivity, that you don't just choose objective measures, that you choose multiple dimensions. And you don't just choose objective measures. You don't just look at telemetry data or whatever it is that you can quantify, that you also look at perceptual subjective data as well. So great question.
So this means that for any kind of analysis about bots, you should do probably always both a quantitative and a qualitative analysis to have.
Oh yeah,
both.
Absolutely. Yeah. Absolutely. Yeah. I mean, I think that's the same with any technology that we use in software engineering. We should be doing qualitative work, and we should be not qualitative work. Sorry, we should be talking to people, you know, and observing them, the developers. We should be studying the impact on developers. Yeah.
Okay.
Yeah. Great.
I see
great
two
question.
hands. Yeah. Sorry. I see 2 hands raised. Perhaps first, Juan Carlos Farah. Can you?
Thank you so much. Thanks again for the fantastic talk. I just have a quick question regarding where do you think it would be most effective to start pushing developers towards creating bots that follow these guidelines? Do you think it should be something similar to what we see on web and front-end development, where certain big companies that have a vested interest in the space will create frameworks like React or Angular and propose guidelines such as I think it's called PWAs, so progressive web apps, in order to push that? Or should it be something more holistic? I'm just wondering, how can we start pushing this into the developers that create bots?
Oh, what a great comment and observation and future research vision in that question. You know, I think there are some guidelines. Actually, I had a master's student for a master's project. She did a project on guidelines for bot design, and I can provide you with the link to that if you like. I wouldn't say our guidelines are validated or completely, you know, use them just out of the box, but it's maybe a start. It was an early research. I think Carly's research as well, and the framework and getting you to think about all of those things are useful as well, but it wasn't designed as guidelines. I think that coming with guidelines and having them updated all the time would be a great idea. And, you know, could address some of the risks, right? You know, that Tom talked about, just thinking about objective measures, and Jose was saying, you know, well, what about, you know, mental health, like understanding the impact of these things, not just, you know, technical aspects, but also the more kind of human and social aspects as well. Yeah, it's a great idea. There are some guidelines out there, but they're very high level and very technical oriented typically. But yeah,
it's one thing that I've seen is that there's a lot of high level guidelines. I think some of them translate to actual guidelines that you can see on ProBot, which is GitHub's framework, right? But it would be nice to see a stronger push towards consolidating some bot design frameworks that incorporate this idea of ideation and empowering developers, not
Like a code of conduct for bots kind of thing as well, perhaps, right?
Exactly.
Yeah, yeah, great idea. Yeah, yeah, thanks.
Okay, I see Jose Serra, who has raised his hand. Jose, can you also?
Alexander has a question. He put in the chat and it wasn't
okay.
addressed first. He was first.
Okay.
Great question. Yes, yes, Alexander, it's true. Most of the superheroes, I mean, you know, they're just the ones that I happen to know. Maybe there are others from other mythology. The other thing that I noticed when I was going through the bots, or not the bots, the superheroes, is that they're most of them are male, right? Finding, you know, female superheroes was a little bit harder as well. So yeah, you know, yeah, let's be careful there with the biases, you know, towards, you know, using, you know, I'm not saying the bot should, I mean, maybe I implied this and I didn't mean to, that the bot should have, you know, the persona of the superhero, but more to sort of to look at the superheroes for inspiration on abilities, right, that we could add to the bots. And then, you know, then we need to be very careful. But you're right, even perhaps the abilities are also somehow, you know, westernized. But again, back to the guidelines question, if you are going to be designing bots, make sure you have a multicultural team, you know, that is diverse, right? Gender diverse as well, right? In designing these bots, make sure that they're not just, you know, for, you know, a very small segment, right, of the population. Okay. Tom, I think.
Yeah, Jose was asking a question, I think.
Yeah.
My question pertains more to this application I've been actually trying to develop. It involves collecting hospital data from a user. So it kind of takes place in this setting, you know, every time you go to the hospital, you get asked these questions. And it reverts back to your subject and objective ways of collecting information. You know, you get asked, how are you feeling? And imagine this, you know, except in the workplace, you know, you do like a constant check-in. Like, you know, all these applications do all these type of measurements, but at the end of the day, like, how would you actually like collect them both together and like not equate, but find a way to differentiate objective and subjective measurement and decide which one has higher priority over the other one?
Okay, so this question relates to all of research. All of our research that we do in software or in any field, in, you know, any socio-technical or any field at all, you know, it's hard. How do you do it? It's very hard, but that doesn't mean we shouldn't try, right? That we should, you know, when we collect data and when we study a phenomenon, if it affects people, we need to study also the people, right? Not just the impact on our code, right? Or the technical artifacts that we create. I mean, one researcher by themselves, they can't necessarily do it, right? If you're, you know, one single researcher, then maybe you're focusing on looking at one thing, but, you know, as a community, we need to take that broad perspective, right? And look at both kinds of data and both perspectives. I saw Puya had a question. Yeah, is there any line on how complex they should be? That's a really good point. I think that question. So the question is, you know, if we spend all this work designing new bots, then it could add more complexity, and how complex should they be? This is the same for any tool that we create for developers to use, that they potentially reduce work in one way, but they add complexity and overhead in another. So yeah, again, we need to be careful. Very, very thoughtful group here today, Tom, in this workshop. It's great.
Okay. So,
I don't know how you are on time. I didn't want
Well, actually, so I was just going to say this. So now we have a break until 17:15, but I don't mind if like part of the audience wants to continue asking you questions. If you don't,
I'm happy
mind,
to stay
either.
here. Yeah.
So for everyone that needs a break, please now is the time until 17:15. But for those that want to stay, we can continue having discussions.
Yeah.
So is there anyone else that wanted to? Yeah. Okay. I see Walid has another question.
No, he's clapping his hands.
Okay. Yeah, just clapping your hands. Okay, right. Actually, I still had another question, which was so.
I can stop sharing. I don't think I need to share.
Yeah,
right?
sure.
Yeah.
It was related to the beginning of your talk. So you found in the beginning you were you found lots of cases in companies that used bots in many different contexts. Actually, so there's two kinds of questions. To which extent to which extent do the bots that are used in companies, are they different from the bots that one can typically find for, I would say, open source software development? I guess, well, as you explained, they are doing quite different things. Do they tend to be more complex? Are they implemented differently? Is there some commonalities or some, perhaps more interesting, some differences that we can actually exploit for trying to make better software development bots?
Yeah, so when you say the bots that are used in industry, do you mean the bots that are used in the software development industry or other industries? Or
that's a good question. Let's start with those that are used in the software development industry. That would be easier, and then you could expand on.
Yeah, I didn't put it to my references, but we had a paper in IEEE software where we talked about some of our experiences studying bots in some companies, and one company in particular. It was a startup company. They use bots in very, very interesting ways, and it's because of a need, right? So they needed to design bots because they didn't have enough people, right, to do all of their tasks, and everything that they did in their company was through this bot framework that they built. When I went to visit them, a bot answered the door. I rang the doorbell and a bot, let me into the building. And they talked about, they were using bots for testing. They were using bots for code review. They were using bots to answer their customers. And it was fascinating to hear how they were using them. And I asked them, near the end of the interview, it was a focus group actually with a bunch of them and telling me how they were using the bots. And not just me, Alexei was with me as well. And at the end of the interview, I said, well, what would happen if your bot framework went down? And they literally went white. They said, oh my God, it would be like somebody turned the lights off in our company, and they hadn't really realized, right, that was a risk. So, that was sort of one experience. If you want to also learn how other larger companies use bots, I didn't look at that for this talk, like what's going on recently. But I know like Atlassian was using a lot of bots. And in fact, the work that I presented in 2016 was inspired by some of their industry talks on how they use bots. I know that there's bot frameworks at Microsoft. Sankey, of course, is one of the bots that's been talked about. They also use Merlin bot. It's not a chat-based bot. I don't know. It's a great question. I think that's perhaps maybe somebody here who's not on a break knows sort of state of the art of how bots are being used in industry. Yeah, it's a great question.
Is there someone else that wants to talk and ask a question to Peggy?
Alexander put a question. Would you argue that bots for automation in general become prominent because developers are expensive? Yeah. I mean, that's a big argument, right? Why we automate in software engineering, right? Because developers are expensive. So you want to automate the stuff that you can automate because companies do, right? They want to automate so that they can save money, right? And, developers are very expensive. But whether you should from the developer perspective or not, that's a question that one has to check, right? So if you automate everything to the point where a developer, say, is bored, in some way, or they're not enjoying the work anymore and they leave, well, that's going to be even more expensive. But yeah, that's the big argument for automation, right? Is to improve productivity, right? At the level of activity, right?
Yeah, actually also related to this, I'm always wondering so everyone takes for granted that bots aim to improve your productivity, otherwise you wouldn't introduce them. But to which extent do actually people that use these bots actually evaluate that whatever productivity that should have been improved after using the bot has actually been improved, and whether it also had any negative consequences?
Exactly. Because you just don't know. And I think, the big thing that we were trying to show with space was that you have to think along these 5 different dimensions, right? Potentially, like you could make somebody super efficient, but they could be bored, or you remove the challenge, right, from their work, or you remove their ability to learn, right? And it may be actually learning how to do the thing that is the part of the job that they really like. And if you automate that away, then they don't like it anymore.
Yeah.
There's always this assumption that, you know, going faster is better. I asked a question once in a workshop on productivity. No, it was continuous deployment. And I asked the engineers in the room what they thought of this and whether they were happier with it. And they said, well, on the one hand, they're happier because their features are reaching their customers faster. And so they see the impact of their work faster. But in another way, they weren't as happy. And they weren't as happy because previously, before continuously deploying features all the time, there were milestones, right? And you would get to the end of, you know, a sprint or, you know, a deployment kind of schedule, and they would deploy and they would have a party, right? And everybody would take, you know, relax for a few days, right, afterwards, because they made this goal and they recognized that they made this goal, and they didn't have this anymore. It was just, you know, this treadmill of continuously working and never feeling like this feeling of closure. I'm done, you know, I've achieved this thing. So, you know, that's like just an example of something that I don't think our industry is super good at looking at, you know, those sort of side effects. There's more questions.
One question.
So Alexander says that they've just going to talk about bots and MDD, model-driven development, and they're the only companies have been are large in their governments. So I was wondering whether developers in these companies are even more expensive than in small Warschaus, etc. Yeah, I don't know. I guess, you know, when it's a large company, they also have the money, right, to spend on the infrastructure, right, on the tooling. And then Jasmine asks, how can we mitigate noise generated by bots? Yeah, you know, for example, code review bots, so that the goal of improving productivity remains. Yeah, it's always a trade-off. And how do we find the right balance? We find the right balance. Well, you know, you don't just find the right balance and stop, right? You continuously have to look at what are you trading off and what are the challenges, and adjusting over time. It's, you know, measuring productivity and even along these 5 dimensions is not easy, right? And you have to continuously keep measuring, right? What's going on, and measuring, and over time changing how you measure and the kinds of questions that you ask. Right, it changes all the time. As soon as you measure something, it's changed. So, and Mariatta has a paper on noise. Yeah, this is a really important point. These bots create a lot of noise and a lot of friction, and it's something that we don't often look at. So, and it's overhead too, right?
Yeah, absolutely.
Yeah, well, thanks.
Okay. So
I'm going to stick around now that I'm awake.
Great, yeah. So thanks for a great talk, as usual.
Thank you. Yeah, it was a little different with the superpower thing. Yeah. I was trying to have some fun.
Okay, so yeah, we start again in 2 minutes from now. So
great. I'm going to go fill up my cup of tea.
Okay,
and,
great.
See you back here.
See you later.
Thank you, everybody. Thank you for the great discussion. Really good discussion. I'm going to write some notes down, and great questions and comments, and lovely to see some friends there. Maybe see some of you at ICSI in a few days.
Thank you very much.
And thanks, Tom, for chairing.
Thank you.
Great. So, hello, everybody. We are starting now our third and last session of BotSE. And in this session, we are going to have 3 paper presentations and also a tutorial from Mariatta. And the first paper presentation is classifying issues into custom labels in Git-Bot. Doja, you can start your presentation.
Yeah. Hello, I am Doja Park, the first author of this paper. The co-authors are Hite Cho and Sana Ri. We are from Gyeongsang National University, South Korea. Today, I present classifying issue into custom labels in Git-Bot. The order of the presentation will proceed as follows. First, I will introduce the background and related work. Second, I will present our proposed approach, TODO Bot. Then I will explain the experimental setup and results. Finally, I will discuss the results and will make a conclusion. As we all know, GitHub plays an important role in managing open source software today. In addition, GitHub provides a labeling system to manage issue efforts of open source software system. Developers also define custom labels by themselves for classifying issues for a specific project. However, it requires a lot of time and efforts for developers to understand the issues and add custom labels. We investigated related studies in the automatic issue classification studies and issue classification related Git-Bot. We found that those studies did not consider custom labels or multi-labeling differently from developers do in GitHub projects. So what we are proposing is the TODO Bot. TODO Bot has been implemented to automatically attach one to several custom labels to an issue report when a project user creates an issue report. In TODO Bot, when a user creates an issue report, GitHub sends a webhook file containing the information in the issue report. TODO Bot then analyzes the webhook file, classifies the custom labels, and automatically attaches the label by calling the relevant APIs. Let me explain the detailed implementation of the TODO Bot. The first step is issue processing. Before the step, we configure an access token. Then in this step, TODO Bot checks if it has access to the projects and receives a webhook file from GitHub if TODO Bot has a permission. After receiving and parsing the webhook file, TODO Bot extracts the data required for labeling and sending the predicted label to GitHub. The second is text pre-processing. In this step, TODO Bot converts all the letters to lowercase and removes any special characters, emoticons, and star bars. Also, to remove unnecessary words such as HTML links, TODO Bot removes words with a length of more than 30 characters. Finally, issue reports with a total length of 5 or less are considered unnecessary, so are removed. Here is the word embedding. Word embedding is the process by which computers can understand natural language. We use fast text because fast text can embed words at a very fast speed, and it has the advantage of embedding out of vocabulary words. Next, we also use the fast text classifier because it is fast learning speed. The important idea of our training is the one-verse-all loss function for multi-labeling classification. The away loss function performs binary classification on each label. Based on the away loss function, TODO Bot classifies labels with predicted value higher than the threshold value. Here we established 3 research questions to evaluate the classification accuracy of Colabot. The first 2 research questions are to find hyperparameters to set up the training model. The first question is to find the threshold value, and the second question is to find the proportion of custom labels to be used in our classification model. The most important part is the research question 3. Here we evaluate the classification accuracy of the single labeling and multi-labeling methods in Colabot. We have collected issue reports by September 9, 2020, as shown in the table. The data we extracted from issue reports are title, description, and labels as shown in the figure. According to result of our first experiment, the highest value is recorded when the threshold value is 0.2. So we trained that we need to set up the threshold as 0.2 for our following experiments. The experiment for RQ1 was conducted based on the threshold value obtained in RQ1. For the experiment, we divided the data by 10% for each label usage and performed a performance evaluation. As a result of the performance evaluation, it was confirmed that the highest performance of field when the label usage top 10%. Based on the result obtained from the previous experiment, ARC1 and ARC2, we experimented on ARC3. When comparing the single labeling method and the multi-labeling method in ARC3, it was found that the multi-labeling method showed a better performance of from 6.7% to 10.9% F1 score. To understand the results of our proposed Colabot, we randomly selected 5 issue reports from GitHub and compared the predicted labels of Colabot with the actual labels attached by developers. We found half of labels are matched. However, some labels are incorrect, so it is needed to find a way of predicting more accurate labels in the future. Now we are in conclusion. First, we propose Colabot gift classifying issues into custom labels. Second, we show the classification accuracy of Colabot.3 research questions. For future work, we will collect more data set to improve the reliability of our evaluation, and we will look for other advanced techniques that can be applied. We would like to do user studies to understand what real users think when using Colabot as well. Thanks for your attention.
Thank you very much for the presentation. Now we have some time for the questions. While we are waiting for the questions from the audience, I can start with some questions. So you presented a bot to classify and label issues on GitHub. And how would you differ this bot from a bot to classify pull requests? Can you use your bot to do so? How much do you need to change? Is it possible to extend your bot to apply for pull requests as well? How do you see it?
Exactly, my listening level is not good. So could you write a chat of your questions? I don't understand what your questions is.
Yeah, sure. I can write.
Oh, full request. Well, actually, previous studies I consider full request, but in issue force, most of users using the full request, of course, but well, consider full requests of things, something artifacts of something issue force artifact is so hard thing and some barrier things of that. So I think that is so hard things. Yeah, I think.
Mhm. And in the future works, you also mentioned user studies. How are
Yeah.
you planning to do these studies?
Oh, well, exactly. I don't plan it. Well, I think well, how can I explain this? Um, well, uh, I think some researchers, I friend to some researchers, other people to using the Colabot, and when people using the Colabot, they have any something like disadvantages or something they think, then um, I I adjust my research. I think it.
Mhm. Good, good. Does anyone have any other questions to ask to Todd? In the chat. Okay, we have another question from Tom Mains. Tom, do you want to unmute yourself and ask?
Yeah,
Oh.
sure. I wrote it down because the speaker wanted to read it. So I will just read the sentence. So what is actually the selling case? So you want to classify issues into custom labels. Why is there actually, what is the need for it? Once you have classified issues into custom labels, for who is this actually useful? Who is going to use these custom labels?
Well, first of all, when I investigated previous studies, I found out that the previous studies classified them into major categories such as bug, enhancement, and crashes. However, users still use custom labels, and as a result, developers have classified labels manually, and it takes a lot of effort, time, and money. From this point of view, I think it can reduce the developers' efforts. So I not only propose useful classification techniques that take custom labels into account, but also automate tasks by suggesting useful bots for developers.
Okay, thank you.
Thank you. Is there any other question?
Oh.
No? Oh.
Yeah, in the chat.
Oh.
Yeah. Oh, that is very interesting questions.
So let me just read the question for the audience. So duplicate label is hard for text classification. Can your model reliably predict duplicate label?
Oh, I also found the duplicate labels, but the duplicate labels, I think that is a very hard thing because consider duplicate is most of issue force duplicates another issue force. So it is a limitation of my consider custom labels. Yeah, so. Oh, maybe future work I consider about the duplicate labels information. Yeah.
Thank you. So I don't see any other question in the chat. So thank you very much for your presentation, Dochen. We can move on for the next one. And the next presentation is on the adoption of a TODO bot on GitHub, a preliminary study. And the presenter will be Hamid.
Oh, is my screen visible?
Yes.
Okay, great.
So you can start.
Well, good afternoon. My name is Hamid Mohayeji. I'm a PhD student from the Eindhoven University of Technology, and it's a pleasure for me to talk to you today about our paper titled on the adoption of the TODO Bot on GitHub, a preliminary study. So in this work, we aim at studying the relationship between self-admitted technical debts and software bots. Specifically, a GitHub bot called the TODO Bot, which converts every to-do comment in a repository into a GitHub issue. To understand the effects of this bot on managing technical debts, we investigate how adopting it makes an impact on the frequency of to-do comments in each repository. Then we compare the life cycle of to-do comments with the life cycle of corresponding GitHub issues. Our results show that adopting the to-do bot increases the number of to-do comments introduced in the repositories. Given that each to-do comment is converted to a GitHub issue by this bot, and the fact that GitHub issues are more likely to be noticed than some to-do comments buried inside code repositories, this rise in the number of to-do comments means the visibility of technical debts associated with them will also increase. Nevertheless, contrary to our initial conjecture, taking on this bot will not enhance the resolution time of those technical debts. Self-admitted technical debts, or SATTs, are the non-optimal or incomplete solutions during the software development process. Such neglected development tasks negatively impact software maintenance and overall quality of the code. It is needless to say that SATTs need to be addressed and eventually removed. The sooner this process takes place, the more desirable its impact would be. Previous research shows that one of the forms by which technical debts can be detected is code comments. Therefore, mining code comments looking for specific patterns, such as to-do comments, are useful for discovering technical debts. Because in the case of a technical debt emerging, developers are often aware that the actual implementation is not optimal. And sometimes they use to-do comments to inform others about the inadequacy of their solution. To-do comments are a specific type of task annotation that developers can use to manage their programming tasks. They are used for a wide variety of jobs, such as splitting up a large task into a smaller subtask or denoting edge cases so that handling their implementation can be deferred to a later point in time. However, without ways to manage to-do comments, they can still be lost track of. And this can lead to technical debt after later on in the project. This is where bots turn out to be useful. So as we know, software bots are one of the most prevailing tools for making software development workflow more efficient. They support different software maintenance and evolution activities, such as code review or executing tests. In addition, they can help developers in managing technical debts. The TODO Bot, a GitHub app created in September 2017, is a great example. This bot automatically creates an issue if a push to the repository's master branch contains the word to do or another pre-configured keyword. For this reason, the TODO Bot can be expected to help manage technical debts by increasing the visibility of to-do comments, as GitHub issues are often more noticeable than code comments placed inside code repositories. So our work contains 3 research questions. For the first one, we aim at understanding to what extent the TODO Bot is being used in GitHub. To this end, we use GitHub Search API to identify issues created by the bot. After removing duplicates, we identified more than 12K issues belonging to more than 2,200 repositories. The majority of these repositories have issues created by the bot within the first 3 days. With regard to general usage of the TODO Bot, our analysis shows that it took around a year after the release of the TODO Bot before its usage actually started to grow. And this growth continued for around half a year. For the second research question, our goal is to learn the characteristics of the repositories that have adopted the TODO Bot. We found that the majority of the repositories using the TODO Bot have less than 25 stars, forks, and watchers. The TODO Bot have been mostly working on repositories with at most few hundred commits. More specifically, about half of the repositories have less than 50 commits. Having said that, the fact that TODO Bot mostly operates on small repositories is not surprising, as according to previous research, more than 90% of GitHub projects have less than 50 commits. Moreover, we observed that the TODO Bot is more popular on recently created projects, where their creation date is less than 1 month before the first issue created by the bot. We conclude from this information that the TODO Bot has been adopted mostly by small and new projects. The reason for this phenomenon remains to be investigated in future work. For now, we conjecture that TODO Bot's behavior in transforming every to-do comment into a GitHub issue could be one of the causes, as not every to-do comment inside the code repository is an indication of technical debt. Our third research question aims at understanding the behavior of developers with respect to to-do comments and correlated issues. To investigate whether the TODO Bot affected the way developers use to-do comments, we analyzed the period of 1 month before and after the first issue created by the bot. We identified a total of approximately 600 repositories that had at least one commit with a to-do comment 1 month before the first issue created by the bot, and also contained issues created by the bot 1 month after. The result of our test on this data indicates that the number of to-do comments after the bot adoption is statistically higher than before. The results confirm our expectation. They reveal that adopting the bot has encouraged the developers to introduce more to-do comments in their code. As our final assessment, we conducted another study aiming to understand whether the adoption of the bot motivated developers to address to-do comments faster. To this end, we obtained the lifespan of to-do comments and compared them with the lifespan of GitHub issues. We consider a to-do comment introduced in a commit result if there is a subsequent commit in which the to-do comment is removed. The time difference between these two commits is considered as the to-do comment's lifespan. In order to achieve this information, we leverage the PyThriller library to traverse every comment in each repository to find to-do comments using a regular expression. This way, we extracted approximately 6,400 to-do comments from our repository source code. Similarly, we calculated the same lifespan for GitHub issues based on their creation and closure dates. So this figure depicts the results of a survival analysis performed on the lifespan data. Here, the x-axis shows the time in weeks, and the y-axis indicates the probability of being unresolved for our samples. The blue curve represents the GitHub issues, and the orange curve illustrates the to-do comments. To our surprise, these results indicate that for periods of over 5 weeks, the probability of being unresolved is lower for to-do comments compared to the issues. In other words, to-do comments are more likely to be resolved after 5 weeks. The exact reason for this behavior needs to be investigated in future work. However, we conjecture that the lifespan of to-do comments and issues is heavily dependent on some factors, such as the complexity of their objectives, which we did not analyze in this work. To summarize, our study shows that the to-do bot motivates developers to put more to-do comments in their code. Taking this into account that each to-do comment will come out in the form of a GitHub issue, we conclude that the to-do bot adoption improves the visibility and observability of technical debts. Nonetheless, our initial analysis shows that it does not make the process of resolving them any faster. For our future research, we can investigate the reasons why the owners of major repositories are not interested in the to-do bot. Also, to find out the effects of to-do bot, we could perform a more comprehensive analysis of the lifespan of to-do comments and issues by considering the complexity of their objectives. Moreover, studying the characteristics of the unresolved GitHub issues could be another research direction, because our initial analysis suggests that converting every to-do comment into a GitHub issue, like what the to-do bot does, is not an optimal solution for increasing the visibility of technical debts. Thank you very much for your attention. If there were any questions, I would be happy to answer.
Great. Thank you very much for your talk, Hamid. It's really nice. I have seen this bot before, and then I have some questions. I think the first one for me would be, how do you identify projects using this bot?
Sorry, I didn't catch your question. Could you repeat it?
Yeah, how do you identify these projects using the bot?
Oh, yes, we use GitHub API with a certain query that contains the username of the bot. And based on the result that we get from GitHub API, we can find out which projects are actually using it.
Mm-hmm. Okay, and how does this bot work? Because I have seen this before, and I saw it as pull request comments, but then it showed an example, and it was really interesting for me to see that it also opens an issue, right?
Yes, the bot is actually open source, so we can learn everything that we want about it. But based on what I have known about it so far, when we push a commit into a repository, it looks for a pattern for to-do comments. If it finds a pattern, automatically creates an issue, and also adds a comment to that GitHub issue and puts the commit hash of that actually triggered that creation. So this is how it works. And also we can configure that to work on other keywords as well. So it doesn't necessarily only work with to do. We can change that to other things as well.
That's interesting. That's interesting. I see that Marvin has posed a question. Marvin, if you want to unmute yourself, or I can also read the question if you want.
Yes. Why should developers, in your opinion, use the to-do bot if it does not improve the resolution time? Well, I think yes. At current state, it seems to be not logical to use such a bot, but we have some conjecture that how we can improve these bots. For example, we have numerous samples in our data set that are related to to-do comments, which seems that there is no need to create an issue for them. For example, the developers have used the to-do comments for communicating with their colleagues. And the to-do bot at its current state creates an issue for it, which seems to be unnecessary. So we believe that our study can enable the developers of this bot to make it better or improve it, and consequently, more people probably will use it. So did you find any negative consequences or effects of using the to-do bot? For example, perhaps developers will be focusing too much on to-do comments and not focus on other important issues. I think one of the negative consequences, as I mentioned, is the creation of irrelevant issues. So it only sees a to-do comment and it creates an issue for it without processing it. So creating a lot of irrelevant issues, in my opinion, is one of the negative consequences. But in the behavior, but if you are talking about the behavior of the developers, we haven't analyzed that. We only know that adopting the bot has enabled them to introduce more to-do comments in their code. That's all.
Mm-hmm. And I have another question, I think, in line with what Marvin asked. Do you see any way that we can measure how these bots help? Because you said that it's like increase the visibility, right? And how this visibility would help developers?
Yes, at the start of our research, we conjectured that this visibility would result in having the issues being resolved faster also, but it seems that it's not the case. So for now, I think the best thing that we can do is to understand why this is happening. Because if we look at this objectively, for example, to-do comments are buried inside a code repository that probably contains lots of files, and GitHub issues are more noticeable, they are more observable by people, and it seems to be that GitHub issues should be resolved faster, but it's not the case. And currently, we don't know an exact answer for it, but I think our next step would be to study why this phenomenon is happening.
Okay. And Tapajit asked, do you have any thoughts on how to improve this bot?
Yes, I think the bot should not create an issue for every to-do comment. I think that's obvious, and our data set shows it as well. So if I were one of the developers of the bot, this is the first step that I would take to make it more smart.
And we have another question from Ben. Did you notice any change that resulted from introducing the TODO Bot into a project? For example, if developers start to get tired of the bot creating all these issues as a result of a to-do comment, they start to use fix me comment instead of to-do comments.
Honestly, we haven't observed something like this, but it seems that the developers are installing the bots and using it for a while, and after that, they are abandoning it. So it is, yes, it is something that we have observed, but that is, I can't comment on that with certainty at current moment.
And what do you consider this bot abandonment in that case? What do you
For
see?
example, maybe abandonment wasn't a good word. The increase in the number of usage of this bot has been, so let me give you an example. In the first 6 months, we see a surge in the number of usage of this bot, but after a while, it is getting more and more less than before. It's getting less, and I think that the popularity of this bot has been increased after its initial surge. The reason for that is currently anonymous to me. I don't know, but maybe the behavior of the bot that simply creates some noise. It creates and it's GitHub issue for every to-do comment. So we might consider it as a type of noise, and it might be the reason that its popularity seems to be decreasing.
Mm-hmm. Thank you. Yeah. We still have time for more questions, so if anyone wants to ask, I think we just have comments in the chat.
Mm-hmm.
Good. I think we don't have any other questions, so thank you so much for your presentation, Hamid. And the next presentation of our session is an exploratory study of reactions to bot comments on GitHub from Juan Carlos.
Yes, so I'm going to share my screen.
Yeah, sure.
Just to confirm that everyone can see it.
Yeah, we can see it.
I'm going to try and go full screen. This is where it can go.
Yes.
Can everyone still see my?
Yes.
Perfect. So I'm just gonna put you on the top right. So thank you everyone for being here. So my name is Juan Carlos Fara. I'm a PhD student at EPFL, the École Polytechnique Fédérale de Lausanne in Switzerland. And today I'll be presenting work that I've done with colleagues, an exploratory study of reactions to bot comments on GitHub. So if we start by just looking at some background information. So as we know, we're here because the popularity of both the social coding platforms like GitHub and GitLab for software development has been steadily rising over the last decade. And on these platforms, there is increasingly more support for developers via the bot interface. And these bots usually interact or often interact using natural language via comments that they can make on the issue or discussion threads on these social development platforms. And some platforms like GitHub have special interfaces or affordances, like a reaction affordance on GitHub, in which users can react to comments in the form of predefined emoji. And these are the 8 emoji reactions available on GitHub. They're quite straightforward, like a thumbs up or a thumbs down, a laugh reaction, a heart, and a couple others. So the idea is that a lot of studies have addressed the use of bots on GitHub, but only a few have actually studied the user bot interaction that happens via the reaction interface. One of these studies from Brown and Parnin was about a specific bot that recommended tools, and they saw that no one interacted with this bot through the reaction interface. And another study was a paper that just proposed general design principles that highlighted the need for bots to take advantage of this reaction interface in the way they interact with developers. And there's also no study, as far as we're concerned, that has investigated specifically how users interact using this laugh reaction, this laughing emoji. And why would this be interesting? Well, there's a long line of research that says that when humor is incorporated into human chatbot interaction, it could be more enjoyable, and that bots could actually harness some of this humor in order to do tasks like recover from errors when a user doesn't understand what that bot is saying, or when the bot acts unexpectedly. So these gaps in the research motivated our study, which essentially aims to better understand how users interact with bots via the reactions affordance. And this, we hope, can help inform the design of the task-oriented bots that can potentially better interpret how users react to the comments that they're posting on these platforms. And then we want to zoom in on the laugh reaction to investigate if there's actually a link between its use on GitHub and humor. And this could help us put into place certain design of bots that could incorporate the proposed affordances that previous researchers have highlighted. So to do this, we performed an observational study where we acquired data from the 2020 GitHub event timeline using GitHub Archive. We extracted events of type issue comment events. So we only focus on comments on issues. And we retrieved reactions to these events using GitHub's REST API. This yielded 3.5 million comments with at least one reaction, of which 3.457 million, so almost most of them, almost all of them were from users. And to differentiate between users and bots, we looked at the type attributes of the user object inside GitHub. So as you can see, the amount of bot comments in this sample is quite small. It's around 0.5% of the total. So what we did with this data is we used a mixed method analysis. So we had some quantitative analysis based on descriptive statistics. And we also did some sentiment analysis where we compared specifically the laugh reaction between bots and human comments. To do this sentiment analysis, we first filtered the comments. So we focused on English comments between 50 and 50,000 characters. And then we performed Vader, which gave us a score from -1 to 1. And we took the distribution and we compared the distribution of Vader scores for human comments and Vader scores for bot comments. And then we did a second sentiment analysis using SentTCR, which is specifically aimed at code review. And this analysis basically classified comments either as non-negative or negative. We then performed the qualitative analysis where we manually inspected 100 randomly selected bots with the laugh reaction. And to analyze this, we were guided by 4 questions. The first one was the reason for the laugh reaction evident? Was the explanation for the laugh reaction dependent on the comment's context, or was the comment on its own enough to explain the laugh reaction? Was the laugh reaction explicitly sought by the bot comment? And finally, was the laugh reaction caused by an incongruity? This means an inconsistency between what the users might expect from the comment and what was actually present in the comment. We then coded each comment to identify common themes in these comments, and then proposed a possible explanation for the presence of the laugh reaction. And our results were organized into 3 main aspects. So the first one was humans versus bots, where we looked at all reactions in general and then zoomed in on the laugh reaction. And we did the same for popular bots. I will explain a little bit how we chose the popular bots in a second, where we did the same thing, all reactions first, and then the laugh reaction as a zoom. And then we did a qualitative analysis on just the laugh reaction, as just mentioned. So if we look at the first aspect, humans versus bots in all reactions, the distribution of reactions follows a similar pattern as the number of comments. So there were 5.4 million reactions to human comments and only 30,000 reactions to bot comments. And the proportion of comments that elicited a reaction was quite different. So humans, 8.92% of human comments elicited a reaction, while bot comments only 0.18%. However, if we look at the proportion of reactions by reaction type, so of all the reactions received, how were these reactions distributed over the 8 different types? We see that overall here in the center, most of the reactions have about the same proportions. However, there's two types of reactions that quite stand out. The first one is the +1 reaction, in which humans tend to get more of the +1 reaction than bots. And the opposite is true for the -1 reaction on the other end of the spectrum. If we zoom in on the laugh reaction, we see that for humans, around 125,000 comments elicited a laugh reaction, while for bots, only 1,000. And again, this is around less than 1% of bots versus users in terms of distribution. And if we zoom in on the graphic that we just saw for the laugh reaction, we don't see that much difference. However, in this case, the number of laugh reactions to the bot seems to be more elevated is higher than for the human comments, which I found quite interesting. We then did the sentiment analysis. So for Vader, the human average was around 0.29, and for the bot, it was almost identical. And when we did the distribution, when we did the analysis using a Mann-Whitney-U test, we saw that the distributions of these scores were not significant, so they were distributed in a similar fashion. And for CENTI-CR, humans received about 83.4% of non-negative comments versus 16.6% of negative comments, and the similar result was present for the bots as well, although bots received surprisingly a bit more non-negative comments than humans. If we look at the popular bots, so what we did is we selected 10 bots that had the largest number of distinct users that reacted at least once to a comment that they posted. And these bots ranged from issue label bot to code-cov bots. So the tasks that they performed were quite varied. And if we look at the distribution similar to what we did for users versus bots, we see that there's a few peaks that stand out. Notably, StaleBot gets a pretty high distribution proportion of negative -1 reactions and confused reactions, whereas WelcomeBot receives quite high peak of heart reactions. There's also issue label bot, which receives quite a high proportion of +1 reactions. And if we look at the box plots, you see that for StaleBot, these are actually outliers. For issue label bot, it's not an outlier, but it's quite up there in the box plot. So if we then take a zoom of the graphic like we did for user versus bots, we see that the proportion of laugh reactions received is actually distributed relatively normal, but there is a peak for GitHub Learning Lab bot, which I will refer to further down in the presentation. And for a qualitative analysis, we followed these 4 questions. So 91 comments, the reason for the presence of the laugh was evident. The dependence on the context, for most of them, they were not dependent on the concept, but some of them were. And for example, here on the right, we see StaleBot posting a comment, and there's a laugh reaction, and it's not evident from the comment itself why there's a laugh reaction. A possible explanation could be the massive difference between the original date of 2015 and 2020 when StaleBot closes it. Obviously, this could be because StaleBot has recently been installed, but it seems to be able to trigger this type of reactions. Then sometimes, or most of the time, the laugh reaction is not explicitly sought. So we only found 2 comments where this was actually explicitly sought. Here's an example. Basically, by using humorous text, you can actually elicit this laugh reaction, in this case, secret island lair. And then the idea of incongruity. So here there's an issue that's been opened that is clearly spam, and the VS Code bot that's experimentally detecting duplicates just finds a correlation between the word support in these 2 issues that clearly have absolutely nothing to do with each other. So this idea of an unexpected reaction from a bot, an unexpected comment from a bot can elicit this laugh reaction. Prominent themes that we saw were tutorials. So this relates to the idea of GitHub Learning bots. So a lot of the times users that were going through the GitHub's tutorial were reacting with this emoji to some of the comments posted by the bot. Then report. So sometimes the bot would present a particular report, say on code quality or some static analysis tool, and it would elicit the reaction. And closing issue, which was mostly StaleBot trying to close issues that were still present and developers having some friction around that action. And was incongruity different by theme? Yes, actually. So the tutorial theme, there was absolutely no incongruity. The report theme, yes, because often it would be reports that made no sense. So it elicited this laughter or this laugh reaction. And then closing issue, again, like I mentioned, StaleBot trying to close things that it shouldn't. So just a quick discussion around these points. So the proportions of the types of reactions are mostly similar across both groups, the humans and bots. One notable exception is that negative -1 reaction, which could be explained because users are more willing to give negative feedback to bots, but it could also be dependent on the bot's task. So obviously StaleBot, which is closing issues that developers want to open, has a very different share of reactions than WelcomeBot that is showing some positive message to users that are just starting. And then reactions also depend on the bot design. So when we closely inspected issue labels bot comments, it shows that it actually asks for a thumbs up or a thumbs down to refine the way it labels issues. So that clearly affected our results. For the laugh reaction specifically, there's no apparent significant differences between how this is used between human and bot comments. And none of the bots stood out in the proportion of laugh reactions received. However, it seems that the laugh reaction can be used not only to express laughter, but also that a user is pleased. So there's no humor involved. This could be due to the fact that the emoji used by GitHub is grinning face with smiling eyes that in some interpretations is not necessarily linked 100% with humor. So when it is used to express humor, it's usually not explicitly sought. It arises from an incongruity most commonly related to an unexpected message. And this has been noted by Borges and his colleagues, saying that the laugh reaction can express sarcasm or irony in negative situations. What we could do with this unanticipated laugh reaction is we could see it as a signal that the bot behavior was not aligned with the user's expectations, and then bots could refine their behavior accordingly to harness potentially the humor underneath and recover from such situations. So our study obviously has some limitations. We've seen how we can detect bots automatically that we could incorporate. We only focused on issue threads. Pull requests should also be a focus. And then some predefined behaviors such as issue label bot that should be taken into consideration. Finally, we would like to increase as well the sample for a qualitative analysis. So with that, I will leave the concluding remarks on the slide and be open to any questions. Thank you very much.
Thank you very much for your presentation, Juan. And we already have at least 3 different questions in the chat. I would ask Tom if he wants to unmute himself and ask the question. Otherwise, I can.
Sure, but I think I know the answer because it was on slide 30. Can you go back to slide 30? I think the
yes.
first bullet.
Slide 29 or 30?
The limitations, yes. Yeah, the limit. Yeah, 29. Yeah. Yeah. Okay. Yeah, because this was actually my question that you don't take into account the bot users that are not labeled as bots. So my question is actually related to this. So to which extent do you think that this might have affected the results of your analysis? Do you think the results might change if you also consider bots that are not labeled as bots by GitHub, but that are actually bot accounts as detected by other tools?
Yeah, so it's a really interesting question. So at the beginning, I thought that what we didn't want was bots that were not evidently bots, because that would kind of skew the analysis in another way. So the user is reacting to some agent that they think is a user, but then looking at the papers of bot detecting algorithms, I think that most of the times it is quite evident that the user is a bot. So I think we should definitely take into consideration. I think what that would do is it would show that those big differences in the proportions are actually still present, but they're a bit smaller.
Yeah. Especially because if you take any GitHub repository that people are working in, the people in this repository, they know what the bots are and what the humans are, even if they are not labeled bots. So
yes.
Yeah. Okay. Thanks.
Great.
Thank you.
And we also have another question from Peggy. So Peggy, if you want to ask.
Yeah, I thought very cool research study, actually. I find it fascinating. I was wondering if you know if any bots have kind of reactions, if they kind of echo back, you know, a smile or a thank you, and if anybody's studied kind of, you know, if such reactions kind of reinforce emotions or lead to other reactions.
Absolutely. So we were looking at the data, and it appears that bots can actually react to other comments. I'm not sure exactly how this is done using the GitHub API, but even without the reaction interface, bots can definitely just post emoji on comments. So that is almost equivalent. The reaction interface is simply, I guess, a quick response button for users in terms of communication. I think that would be most likely the part of the loop. So the idea that we're proposing or that we've seen is to take what issue label bot does and expand it so that the bot actually has an expectation of what it's supposed to elicit in users. And if there's some sort of incongruity in what it's receiving as a signal, so if it's expecting a lot of plus, like thumbs up, and it's getting a lot of thumbs down, then it could harness that to post a separate message. And then if that interaction continues, it could involve also the use of emoji from the bot's part to, say, smooth out any tensions that might have existed. I feel bad for Stalebot, because as I was going through those comments, it does arise, like not just the conversations between Stalebot and the user, but also between users around Stalebot. So you could imagine a particularly positive use case of that interface.
I love that you feel bad for a bot.
I'm guilty of that anthropomorphization.
We have another question. Sivasuriya, you want to unmute yourself?
Hi, Ivan. Thanks for the presentation. It was really nice. So yeah, my question was, you have shown us the slides of one or two reactions, like the law of reactions on the comments. Was that all the data that you had, or there were data where there were lots of reactions and then you chose to just pick these ones so that just as an outlier? Because I just thought like maybe people just randomly clicked some of these reactions by mistake, and yeah, it's not a good thing to base conclusions upon this, right?
Absolutely. That's one of the things that motivates this study, is that we want to do a much larger scale study where we look at a much larger sample. The examples that I've chosen are also used for presentation purposes because it's actually funny or relatively interesting comments. There are, especially when it comes to closing comments, there's sometimes a wide variety of reactions, which obviously opens another sort of Pandora's box of what does it mean to have conflicting reactions from users to a particular comment. That could be a way to signal that the comment is particularly interesting. But we were using this study as a first step towards analyzing the data at a much broader scale. And we're hoping to actually borrow from how the taxonomy of laughter in social science in order to analyze how this reaction is used virtually on social coding platforms like GitHub. Of course, one of the things that we also need to take into consideration is that emojis don't necessarily map one-to-one for everyone. So for someone might be a laugh reaction, for someone else might be a smiling reaction, and so on and so forth. Thank you.
Good. Thank you very much for your presentation and for answering the questions. I think we don't have any other questions, so thank you.
Thank you very much.
And now, also following the same line of presentations that we had in this session, we are continuing talking about GitHub bots with Mariatta. I'm really happy to have her here with us. So Mariatta has over 15 years of experience in the software industry. She's a Python core developer and contributes to various open source projects. And she's working as a senior developer relations engineer at Google. And today she's going to talk about bots on GitHub and how to create those bots. And her presentation is Say It with Bots. So Mariatta, the floor is yours. You can share your slides and present.
All right, thank you everyone. Just checking if you all can hear me okay?
Yeah.
All right, great. Let me share my screen. Let's see how this works. Okay. I'm not sure. Do you see my screen now? Okay. All right, let's do this. Thank you so much. Yes, so I'm giving this talk, I call it Say It with Bots instead of Say It with Flowers. Basically, the idea is to thank your contributors and tell it using bots. So yeah, my name is Mariatta, and I'm one of the Python core developers. And what it means is that I'm one of the maintainer of the Python programming language. And as part of my work maintaining Python, what I look after is our GitHub bots, our workflow automation that we use to maintain, to help with the work, to help with the maintaining the project, basically making sure we look after all the contributors, make sure we have the time to actually review all those pull requests and issues instead of trying to do manual things like closing an issue. We delegate many tasks to bots. Professionally, I work as a senior developer relations engineer at Google Cloud specifically, and I'm in Vancouver, Canada, and you can find me on GitHub and Twitter, and my handle is Mariatta. So in this session, I just want to talk about how you can implement such bot on GitHub and using Python. And so like throughout this whole conference, you've been learning about various topics related to bots. So in this here, we're just talking about how to write one using Python. Now, I also want to say we have a short time. Usually my full tutorial on building this will take about at least 1 hour to 2 hours. So what I will show here instead of like doing live demos, because it's complicated, I need to keep switching my screen. I will just explain the different pieces needed, the architecture of a GitHub bots. And then I also have the links to more in-depth tutorial, which you can follow in your own free time after this. And all the links here is actually, I have these slides online. Let me share it to you before I forget. I will share it on the chat. So you will have all the links that you can use later to build the bot yourself. So, all right, I posted in chat. And the necessary library for building the GitHub bot in using Python, I recommend using the GitHub library, which is an open source library. It is also a library that I help maintain. And you will need to be reading GitHub API documentation at the same time while building your GitHub bots. So I always like to share these two resources, the GitHub library and the GitHub API documentation. I'm always reading both at the same time when building my bot. Now, I'll start with the GitHub library, why this will be useful for building your bot your GitHub bot. I've shared the links there, so github.readerdocs.io, and as mentioned, it is open source. It is Apache licensed, so go to github.com/Brad Cannon. Brad Cannon is the maintainer, the creator of this library, /git GitHub. So this library is an asynchronous library. So it uses Python's async IO for working with GitHub APIs. And not only it works with APIs, it also handles GitHub webhook events. I'll talk more about what webhooks are. And it requires Python 3.6, so pretty modern. I recommend you use the recent Python version. I think we will have Python 3.11 soon, but it will work starting in Python 3.6. And it has convenient utilities for working with GitHub APIs, for handling GitHub authentication, for handling all the GitHub webhook event validation, also formatting URLs for GitHub. And this also support if you have enterprise GitHub, which is if you use the hosted GitHub, all the URLs will be api.github.com. And if you are using, your corporation have an enterprise GitHub, the URL will be different. It will not be github.com. This library is capable of handling that. And yes, all the routings for GitHub webhook handlers. So this is an example of a GitHub bot. This is a bot I built a couple of years ago. This was a bot I made to show how it works. Basically, you can see that this is an issue on GitHub. It was created by a bot. It has the label bot, and then it says thank you. And once the bot creates this issue, it automatically closes it. So that's an automation, right? So how does this all work? Basically, in my mind, a bot is not just a program that runs automatically, but it reacts to certain events, automatically responding to, say, user actions. So the way this whole things work is that GitHub can send you webhook events. It has a lot of data. So it makes a request to your bot, and your bot will be a web service. And your bot receives these webhook events and then reacts to it by making API calls from your service to GitHub. So it's two-part, receiving a webhook event and then making API calls. And so more details about webhook events from GitHub. You can read even more thorough information about this on the URL in the documentation, which I shared here. But the summary is this. GitHub sends you HTTP post request to your web service, and you get to configure what is this URL looks like. You get to configure your own like web server. And GitHub will be sending you always a post request, not any other types. And it will send you specific headers like X GitHub something. And depending on the types of events, there are lots of event types. For example, events related to pull requests, issues or reviews. GitHub will send you different kind of objects. And the good thing with a GitHub is that it handles this kind of headers. It verifies and validates that requests coming to your web service indeed comes from GitHub. So in case people is trying to say, make requests to your server without the proper headers, it will reject it. It will not do anything. And that's important to make sure your web service can stay secure. You need to know that the requests are coming for GitHub. So that was the webhook, and calling GitHub APIs, that's the other direction from your web service to GitHub. And this will represent different kind of actions. So GitHub APIs. There are lots of APIs you can use, and there's a full list on it in that documentation that I shared. Basically, you have an API for opening an issue, commenting an issue, or you want to close or an issue or pull request. There are lots of different actions, different APIs. So you will have to think about how you want your bot to behave. So basically, you will be making GitHub API calls, and this is something you can do with GitHub library. You will need to authenticate using an OAuth token, and when webhook set up, when GitHub sends you webhook events, it's always in the post request. In API calls, you can send various things like get, post, put, and delete. Those are supported. So all of these API calls, you can use the GitHub library in Python. So how do you get started using the GitHub library? You will need to install install the dependencies, and I have a very thorough step-by-steps on how to install it in that documentation link that I put onto the top. You will also need to obtain a personal access token from GitHub. And again, the process is mentioned in that documentation. So once you have the personal access token, you can use the GitHub library to make API calls, and then that's how GitHub will know that these API calls are coming from you because you created this personal access token. And the access tokens are created on the GitHub site. So I think you have to go to your GitHub profile settings, and then there is a developer settings. There you will see a menu, like a link on the left for generating a new personal access token. So once you have the libraries, you have the access token, you can start using the GitHub library to start making API calls. So I'm showing an example here of how you would use GitHub to create an issue. On the top part, you'll see that is actually, I took it from GitHub's API documentation. It tells you that to create an issue using API, you will make a post request to that URL, to repos/owner/repo/issues, and then you need to provide several parameters. The title parameter is required, and the body is not required, but you can pass it. But so it will actually tells you what are the accepted parameters. So on the bottom is how you will do that using Python, using GitHub library. Basically, that's how I showed you the syntax of how you will be making a post request to that specific URL as written in the documentation, and how you would pass in the parameters as needed, so that you will pass it in the data and you will pass the title and the body. Here's another example. Basically, it's pretty much the same, but just to demonstrate how you would use the library. This is another API endpoint. On the top part is the API endpoint that is written in GitHub documentation of how you can create an issue comment, basically commenting on an issue. You would make a post request to that URL. You will need to change the owner repo issue number, and it requires one parameter, the body. Basically, that the body here will be the comment of will be the comment that you want to leave, and in the bottom, that's how you would do it using GitHub. You'd call like gh.post, and then pass in the URL as needed, and then you pass the data in the body like that. That's the syntax for making this API call. So let's talk about GitHub webhook events. As mentioned earlier, GitHub sends you post requests with specific headers. It also have a very thorough documentation of what is the data that GitHub is sending you. So once you read the documentation, you can understand how to process the data. It says every webhook event has a common properties. It will always send these types of data in the payload. It will always have an action, a sender, a repository, and an installation if you have set it up as a GitHub app. So your webhook event handler will need to be able to handle all of this kind of information. Then depending on what type of events, what type of webhook events, GitHub will additionally send you different objects in the data. So here I'm sharing the events that comes when you have an issue related event. The documentation tells you that GitHub will send something like it, something that says an action, which is a string. An action will be like opened, edited, closed. So you get to know whether this issue was opened or whether somebody closed an issue. You have to look at the action. And then it will actually send you the actual issue object itself. For example, it's really, really long. It's really big. So I strip it down. Basically, you will always find like the issue number and the title. So when you receive this data, you can decide what you want to do with this data. So, but you will get a lot of information about the issue. So this is how the webhook data is being sent by GitHub to your service. So how do you handle this information using GitHub? I posted a snippet of how you do it. If you look at the first line there at router.register issue, action equal opened. This is where I'm telling my bot, my web service, that I want to, this is how I want to handle the issue opened event. In this case, any other event is not handled in this coroutine, only the issue opened. So I created an event handler this way, and in my workflow, I decided, for example, if I decided if somebody opened an issue, I want to just say, hey, thank you for opening an issue, right? So I received the webhook event, the issue open event, and then I will need to make an API call to say thank you for opening an issue. So that's where I would call the post, the gh.post. That's the syntax for making the API call to the issue, and then that's how I would pass the message. So this is to demonstrate how I would receive the issue open event and then immediately posting a comment and saying thanks. Now, once you understand, once you have built all of these pieces, you have the webhook event handlers, you know how to make API calls, you need to combine all of this together, and you will need to actually create a GitHub app. So basically, you can go to GitHub and create this app. That's where you will tell GitHub that this is where my webhook URL is going to be. And you can tell GitHub that I only want to subscribe to specific webhook events, depending on the bot you're building, what kind of workflow you're having. So I really recommend that you don't choose all the events because it will be very busy. So you will see a UI, like a user interface on GitHub, where you say, I only want, say, the webhook, the issues events or the pull request events. So you have to check which events from GitHub that you want. And when you build that, when you create that app on GitHub, that's where you will also need to create a private key, and it's all like on the UI. Basically, you click some buttons. you will need to use this private key for authentication. This is how you can tell your bot and GitHub that all API calls is actually made by your bot. That's how GitHub will knows that you are the bot who is using this app. So there's a lot of steps there. I did not take screenshots because if you actually click on that link on the top, it's really long and I didn't want to waste time or duplicate information. So that link on the top there, follow it step by steps to create the GitHub app. Now you can see some examples. I have a fully working bot that I have implemented and written. I have shared this. I usually share this as a tutorial when I have the 2-hour session available. However, in this time slot, it's not possible to share, but go to that link and you will see the full source code of working example of a GitHub bot. And I also suggest that when you go to the GitHub repository, switch to the different branches. You will see I have a different branches for saying thanks or for handling PR opened. And once you switch the branch, you will see full working code of a bot. And to see a more thorough, like step-by-steps with all the screens, all the necessary little steps, go to my tutorial, the GitHub app tutorial so GitHub app tutorial.readthedocs.io. That's my complete step-by-step tutorial for building a GitHub bot using GitHub. And yes, I do recommend allocating at least 1 or 2 hours because it is a lengthy process, lots of different pieces. And as I've shown it, like you need to read the documentation, you need to set up the GitHub app, you need to write the code, like different screens. It's just difficult to show in this setting right now. So yes, so I'm sorry, but thank you. Just want to say thank you so much for inviting me. I'm so excited to be here. It's an honor to close out this whole session. I hope you learned a lot about bots, and I hope you will follow my tutorial and build your own GitHub bots. Again, it's not long, it's like 2 hours. I'm sure you can do it. So thank you so much, everybody, for listening.
Thank you, Mariatta, for your presentation. It was really nice. And we have time now for questions. So if you have any question, you can raise your hand or post it in the chat and we can read. Okay. Yeah, I can start. So I'm curious about, because you explained the process on how to create a bot and how to integrate this bot into GitHub. But then when you need to test the bot that you just created, how do you do it?
Yes, so you can write unit tests, but you can write unit tests, the functions for sure. But to actually test it, what I normally do is actually run the bot. So actually deploy the web service. And then I would install it in a personal repo, just to see that you receive all these webhook events. There's no other way to receive it unless you set it up, you tell GitHub that, hey, send all these webhook events to this service, right? So normally I have a test repository just for the purpose of testing out the bot. And I will share basically, definitely don't test this on real repositories unless you're really, really sure. Don't test it on other people's repository. Don't spam them. Just test it on your own. And for me, I have this personal repo. Let me share it to you. If I'll see. Am I still sharing screen?
Yeah, you are.
Yeah. So this is my test repo that if you read the tutorial, you will see this URL. I have like random text, and when people are taking my tutorial, I've given them the permission to just test it on my repo. So these are all the bots that people are building and testing. So just this is not even my bot. This is somebody else's bot. Like have a test. It's okay to test it on a real repository, but your own for something that's for something that is purposely created just for testing. So don't spam people. Yeah.
Good. I think we have another question from Mehdi. Mehdi, if you want to unmute yourself and ask Mariatta.
Hello. Thank you, Mariatta. It was a great presentation, and I learned a lot. Actually, I have experience creating bots using Python, but I was wondering if anyone knows any similar example to create such bots using PHP, because when I create it using Python, it's not possible to run it in my web host. I should run it in my own computer, which is not always on. But in my web,
okay.
it's on PHP. If it's PHP, I can run it in my web host. So I am free, and it will work whenever I'm not on my computer. So that was my question.
So yes, so two things that come to my mind. First of all, I think, well, you use it on your web host. I assume it's just for testing, right? But maybe it's not. In my mind, that you want your bot to always be working. So ideally, you have it always running. However, I remember you can definitely build this using other programming languages. GitHub has a list of other libraries you can use for working with their APIs. However, I'm not sure if they have a PHP. I know they have like JavaScript or Node.js. So if you, I will try to see immediately if I can find it. But definitely the GitHub documentation, you will find the link there. I will try to find the link after this. You don't need to use Python. That's what I'm saying. They do. I mean, basically, it's receiving, REST requests, right? If PHP can do that, then you can do that. And for making API calls, you can definitely use any other library programming languages as well. There are supports for that because it's basically, you're hitting GitHub API endpoints. The libraries, like I mentioned, GitHub, it simply provides the abstraction for it, because when you make those API requests, the get or post, not only you're hitting a URL, you also need to supply certain request headers for your authentication. And in GitHub, they abstract that out. Like it simplifies such that you don't need to manually construct those headers. It's done underneath the library. You only need to supply the actual authentication string. So if you don't use libraries like GitHub, there are other libraries available in other language. If you don't use libraries, you will have to do this, a lot of like this little work like authentication on your own. So
yeah, exactly, because I wrote some parts and it was working. I wrote it from the scratch, not using any API, any library, but when I received the API call, but I could not send the data to GitHub APIs because I had some problem loading a public key in libraries using PHP. So no problem. Thank you very much.
So do we have any other questions from the audience?
I think I found, sorry, just to follow up, I found the URL where GitHub shares a list of libraries for working with GitHub APIs in the different languages. So I've just posted on the chat so you can go through those links. Do they have PHP? Yeah, there is some libraries in PHP that you might want to check.
Okay, thank you very much. Yeah, I don't think we have any other questions. So thank you very much for accepting our invitation, Mariatta. It was really nice to hear your talk. And
thank you.
Thank you.
Thank you so much.
So Stefan and Tom, we can.
I'm here.
We can start the next part, the discussion, I think.
Where's the noise coming from? This was apparently from Stefan. I muted him. Let me check if I unmute again, what happens. No. I don't know, Stefan, but there is something very strange. So while Stefan is trying to fix this problem, so basically now we have like the discussion section based on everything that you have heard during the entire day about bots. Is there anything that the audience would like to raise? Any particular discussion questions we could talk about? I have some, but I would like first to give the floor to the audience. So not hearing any reactions. Okay, so one of the things we have heard in like a couple of different presentations was, okay, so let's say the main, many of the presentations today were focusing on software development bots, either by proposing them or by analyzing them. But there were also some that were looking at, and there were some questions as well about bots that are outside of the software engineering or software development spectrum. So one of the questions is, to which extent can we learn about things that have been done in the context of non-software engineering, non-software development bots, and apply them in the context of software development bots? So there is many different aspects to this question. So I don't want to bias the answers in any way. But for example, one of the things that I personally have always been wondering is, and it was also one of the questions that was raised during the bot detection, one of the bot detection presentations, is For example, to which extent we all know about chatbots. There is lots of tools that are quite efficient in detecting whether something is a chatbot. On the other hand, chatbots are becoming always more and more smart to try to not reveal their identity. So one of the questions there is to which extent like techniques that have been used for detecting chatbots or other types of bots could be applied in the context of software development bots to have even much better techniques for detecting bots in software development. So this is like, for me, this is an open question. I don't know if there's any reactions on this. Because everyone is tired from a long day of workshop.
So yeah, I'll just give my 2 cents on it. So in the paper that we wrote on bots and software engineering, this systematic mapping study, there was a discussion about is it okay if bots disguise themselves as humans so that it's actually accepted as a part of the development community? And there are both merits and demerits in this case as well. So for example, I'm sorry, I don't really remember the name of the paper, where they actually created a bot in the Stack Overflow and let it run for 90 days. And it actually received a lot of upvotes, and there were the community support was really good under the disguise of a normal human user. But after the 90 days, they actually tried it with explicitly, it was actually named as a bot. And I guess in 15 days, it got lots of downvotes, and eventually it was banned in the Stack Overflow. So the conclusion that they drew was like, okay, so if in a disguise, people actually trust these bots, but if it was explicitly mentioned that, okay, I'm a bot, then people are not actually trusting it. So this actually completely changes that if they're useful for the community or not. And but just because if it's a bot, people don't really want to trust because of maybe their smartness or the trustworthiness behind it. So yeah, it was just one of the discussion points that we have discussed in the paper.
Yeah. It's a quite interesting question in the sense that, okay, this was specifically for Stack Overflow. So if you take chatbots in general, there were many of these bots that actually try to disguise themselves as being humans. I'm actually wondering if, I've always been wondering about the question, is there actually, is anyone aware of having like development bots that purposefully try to distinguish themselves as humans in a context like GitHub or other social coding platforms or other development platforms? And if that would be the case, would there actually be any reason for bots or rather the developers of these bots to do so? Does anyone have already had this experience of bots that, especially development bots, that actually try to be as human as possible to gain more trust?
Just one question. You mean like bots that could code by themselves, or more like doing other open issues on other bots?
It could be any type of, it could be any type of activity that the bots are doing. It's like if we look at during our bot detection analysis, we were doing actually a manual verification about whether something is a bot and human. And in like the large majority of the cases, we could actually clearly see whether something was a bot or not based on like repetitive patterns. And we were never actually able to find something that even remotely looked like a chatbot, something that was really trying to behave like a human. I guess this would be more the case in issues than in pull requests, because there you have more commenting. but we have never found such a thing. So, okay, perhaps one of the reasons why we didn't find it is because we were not looking for like a human behavior in bots. But so I don't know if like some of the things that you see, like a behavior of bots, chatbots, that try to behave like humans, if this is actually a non-issue in for development bots, or is it something that is actually more likely to appear more and more frequently in the future? So since bots are becoming more smarter, or should be, at least there was a paper that said, well, bots are becoming more and more complex, bots are becoming more smarter. As a result, they are perhaps also more likely to behave like humans, making them more difficult to distinguish from humans. I don't know, this is like a prediction for the future. I don't know if this is actually will happen, but if this is the case, then probably we will need techniques like for chatbot detection and apply them also in a development context. But for now, I haven't seen any compelling evidence of this happening. So that was why I was asking the question, if perhaps someone else has seen.
Yeah, I think Mariatta raised.
Yes.
Yeah, thank you. So I did see something similar. I think this is definitely being researched, or people are trying to do it using AI for sure. Recently I watched a video about, it's a Google AI. Sorry, I do work at Google, and this is coincidence. I was not trying to bring it up or advertise, but I saw a video of Google CEO demonstrating this behavior using Google Voice. So he's telling the bot, I don't know the product, but he's telling this bot to make a phone call for a haircut appointment. And the bot is actually dialing the hair salon or something on the surface, saying, I want to make an appointment, but it wasn't a robotic sound, it's human sound. And as well, when the human responded saying, oh, I don't have an appointment at this time, the bot actually uses phrases like, let me think, how about, instead of immediately saying, okay, I can't, in that case, like instead of saying something robotic, if not today, what about tomorrow? It has some emotion like built in. So I think that's something that is being researched, and those are the ways you can add in human element like emotion. So I will try to find it, or somebody has shown it. It looks like somebody. Okay, Google Duplex, maybe, yeah.
Tom, I think you are muted.
Yeah, sorry. Yeah, indeed. Sorry. So I think it's also quite related to the presentation by Juan Carlos, who also has looked at the use of emoticons in bots. So I don't know if you can comment on this discussion, Juan Carlos.
Yeah, I was just going to say one thing about, because I know the Stack Overflow study that Sivasurya mentioned. I think specifically for chatbots or for bots acting like humans, it really depends on the platform and the platform's policies towards bot users. I tend to think that platforms like Stack Overflow that are usually very, very well, I mean, they're very strict in terms of what you can post, who can post, what type of format you need to follow, tend to be a bit more closed. And therefore, that's possibly what could have prompted that reaction towards the bot sort of outing itself as a bot. Other platforms like Twitter have seen that change, right? Of we don't want any bots on Twitter, and then suddenly accepting that bots are going to be a part of Twitter and having them have to acknowledge themselves. My kind of hypothesis is that because each platform has a specific community, we need to look at how the community interacts with each other and with bots. And I tend to think that development communities are usually quite open towards interacting with bots. Some of the comments that I saw were very human-like. You could have imagined a colleague posting that type of bot. But as I was looking at comments, the type of comments, sorry, as I was looking at comments that were explicitly from bots, it was immediate. It was evident that it was a bot. However, some of the interactions, if you would have just replaced the bot name for a developer name, you could have been tricked. So I think that when going forward towards how human-like bots should be, I tend to follow GitHub's recommendations that bots are still bots, so they should be evidently bots and they should be designed to be bots. But I think that they should incorporate interactions that we find pleasant, and I think that's kind of a good way to move forward to bringing both sides of the coin in design.
Yeah. So do you mean like, if you have bots on GitHub, as long as you know that they are like explicitly labeled as bots, it's okay that they exhibit human behavior, because you can always see that it's a bot that's interacting with you.
Yeah, that tends to be my opinion.
Mm-hmm. Okay. There was also another. So I'm just going over. I don't want to steal the entire discussion. Perhaps, I don't know, Marielle, did you raise your hand or no? No, okay. I don't want to steal the entire discussion today. So if you have if anyone has anything to discuss or to talk about, just put it in the Skype. Sorry, the chat.
I think someone raised.
Yes. Okay. I see. Yes.
Okay, it's me. Yeah. So yeah, one of the reason I believe that that these bots having designed with the human emotions is because with more and more development of bots and with their increase in smartness, developers actually want yeah, developers don't actually think bots as just as a tool, but more as a companion or a part of the whole development community. So as they get smarter and smarter, it's also the job of the bot designer to actually make the bot with a better persona, so that it's actually well integrated within the community, so that it's actually good for collaboration and everything. But of course, the question remains then, should the bot still be named as a bot, or if you are at the point that we actually wholeheartedly accept the bot as a part of the community, that we even think of it as our fellow developer with just a human name, it's still a debatable question. But but this emotional part of the bot is for sure contributes to the design of the bot persona. Yeah.
Okay. Thanks for this reflection. I don't know if anyone wants to comment on this. I see there's also another question by Mohammed. Can you please raise your question if you want to? I don't know if it's a question or a comment.
Hi.
Yeah, hello.
Hi. So it's more of a question, because I went through a few papers also outside of this conference, and I was really interested in what kind of cases, which kind of metric is more suitable and that supports what we have done or the output of the model and gains trust of the end user or people who are using the trained model for some reason.
This is quite a generic question. So how does this? Sorry, I'm not sure if I understand exactly how to. Yeah. I personally, I didn't really get your question exactly. Sorry. Perhaps someone else is. Perhaps it's just me. I'm getting tired. No.
I think he's asking more about which metrics should be used to when developing bots for, because he also put a comment on precision and recall, but I don't know how to answer.
Because it really depends on the type of thing you're focusing on. Like, is it for analyzing the presence of bots? Is it for for detecting bots? Is it for something else? Like, okay, I can perhaps comment on this one in particular, like precision and recall. If it would be for detecting bots, suppose you have a bot detection tool. If your tool is able to very reliably detect the presence of bots, and occasionally within all the bots detected, there is some human in the list, that's not too bad. If on the other hand, the opposite case, your tool is not able, well, the tool is not identifying bots because they are in a list of, and they are just like classified in the list of humans. This is much worse because there is much less bots than there are humans. So in that particular case, it's much more important to have a higher recall than a precision. So which type of metric you prefer depends on the particular case that you're focusing on. So I guess this is always specific to the type of like classification approach or machine learning thing that you want to focus on. I don't think there's one single unique answer to this question. It depends on what you're looking at, I think.
I have a question for the group, if I can.
Sure.
So one of the topics that we work on in our lab is on bots in educational software, and specifically in software engineering software. So one of the questions that I would have is, what do you think would be some good strategies to, say, create easy or not, like distilled down like versions of bots that you would see on GitHub that you could use to teach software engineering, and not just software engineering, but teach students, like first-year students, to incorporate bots into their software engineering practice from the beginning, because static tool analysis are very important, but most of the time it's bots that are running these, or you're running it locally. And sometimes what we've seen is that students are overwhelmed when they go from the classroom to GitHub, and suddenly there's 100 things going on in the pull request, and they don't really know how to parse that. Have you seen any work regarding this, or any suggestions? I think you're muted, Tom.
So from my personal experience, I tend to agree with you. I haven't seen any research on this, but whenever I'm trying to show or provide experience to my students in the software engineering course to bots and to GitHub and how everything works, already just getting them to learn GitHub by itself can be quite overwhelming, because they, if the first time they see all of this, first of all, the first time they have to properly start using Git, and then on top of this, all of the features of GitHub, like issues, discussions, and so on, it's already quite overwhelming. Once they master this, so I think you have to do this in a gradual step. First, learning them to use properly Git, then learning them to use all the features of GitHub, or at least the most important ones, and then starting to use more advanced features, which could either be bots or GitHub actions, but in a limited way. So, for example, well, as you mentioned, it could be starting to implement, for example, automatic building and testing, unit testing within your GitHub workflow. This would be just one bot that is automatic, could be a bot or a GitHub action that's automatically run. Once they get familiar with this, then you can show them some other bots that might be useful. And like this, gradually, you add more and more bots starting from the moment that they become familiar with the previous one. So I think this seems to be a nice way to do it. And after a while, after having experience with a couple of bots like this, they basically start finding out other bots from themselves that they think could be useful to integrate by themselves.
Thank you.
Yeah, what is the best way? What's the best way? I don't know, because there is not really, I think, not really any research having been done specifically on this.
Thank you. I mean, that's really good feedback, because one of the things that, so it's interesting that you said that you start with Git, so you actually do sort of have that as a basis, because I was also thinking maybe that is already quite a high bar, not for software engineering students, but for students that are looking to learn how to program. So I was thinking potentially, how could bots be integrated into things like Jupyter notebooks, or things that are aimed more at still development, but non-software engineering development?
Yeah, I understand. That's a great question. Well, unfortunately, I only have a computer science student, so I don't have this issue. But yeah, I see the point.
I think, yeah, thank you for the feedback. It's very interesting. I think it's an interesting area of research.
I don't know if anyone else can reflect on this.
I have something else, because we touched upon in the beginning about chatbots, and also Mariatta gave the example of Google. I would like to present a bit about my experience trying to develop a chatbot, and I saw that it was these platforms, and they were really thought, and they are really good at identifying clear intents in the, I would say, simple examples. As she said, oh, call, or like assistance, call someone, do something. So when you try to do something a bit more complicated, a different, put a structure more a bit open, and it's really hard to identify the pieces of the sentences. It becomes really yeah, the performance degrades really a lot. So I don't know, maybe we are trying to do something that the technology of chatbots hasn't arrived yet. I don't expect any of us here as software engineers to develop the new natural language processing advances in research we are just using. But I don't know, what I see now, maybe we are maybe what we need is still a bit ahead. Maybe we need a little bit more. Of course, when you see these examples and companies showing, looks amazing. And of course, they really useful, like Siri and Alexa and Google Assistant. They really work. But for these clear things, when you need to make them, let's say, understand something a bit more complex, it's really hard. At least my experience, to make them think. Yeah, I don't know if you can help someone with anything, this reflection, but yeah.
Okay, thank you. Okay, I see that Tapajit also raised his hand.
Hi, so I wanted to say one thing, since we are kind of talking about bots. So maybe for helping the first year students, the GitHub Copilot tool might be something to check out. So I'm not sure how everyone feels about the tool. It is known to have a lot of problems also. So I'm not sure if that is the best way of going forward for someone who is just trying to learn how to code, but it might be something interesting to see also.
Does anyone have experience with using this Copilot tool with his students?
I have used that in a like a sandbox kind of thing. It worked well for me. So I was trying with Python mostly. It worked pretty well for me.
I didn't have the occasion to use it yet myself, unfortunately.
I tried it as in the context of a master's thesis that I was supervising, and I think it's as you mentioned, Tabajit, it has some pros and some cons. Essentially, I ended up uninstalling it and telling the student that I was working it to uninstall it because it was just too noisy. But I feel that there's potential there, definitely.
So going forward with bots, do you think that, most of the bots that we are talking about here, I think are sort of chat bots or something that helps the whole flow of writing code, whereas the Copilot tool is something that like works as an extra developer, basically. So what would you all think that the way to go forward? Like, should it be something that helps the developers, like we have like something that sorts out issues, pull requests, or something that helps them write code like the Copilot tool? So just a question.
I think the question is different in the sense that like helping someone to sort out issues and pull requests is especially useful if you are really in large development teams, while the Copilot might be useful for smaller scale projects. So it depends on the context.
Yeah.
I also think there's potential, again, once more in the educational domain. I think tools that are not evident what they're doing can sometimes make it a bit more complicated for students to actually understand what's going on. And especially when you're talking about younger students, I think that there's a number of not actual software bots, but actual physical robots that are used to teach programming to young children. And I think that could be enhanced by a framework that is a bit more general in how humans interact with bots that help software development. So you could start at a much earlier age as saying, this type of bot helps you write clean code. And clean code is important because of this and that reason. And that people see it throughout their education as things like computational thinking become more ubiquitous in curricula.
Yeah, nice thoughts. Okay, I don't know if anyone else still has something to raise for this discussion session.
I do have one more thing to say also. I was just thinking about this thing that a bot might work as a second developer in a project. From that sense, what do you think should be sort of the profile picture for those bots? Should it be some, like, mostly what we see here are Jenkins has butlers and these things, whereas some other bots have like those pixelated bot type of pictures. So is that the way that it should be, or should it be something else? That since we also talked about creating some sort of personas for these bots, having a nice picture, I would say that it makes the whole thing more approachable also.
Well, I think the answer is clear. They should also all be superheroes, right?
Yeah.
Okay, I suggest if no one else has anything to raise, that we go to the closing session of today's workshop. I will ask Mayuri to take over. Yes.
I think it's Stefan moved.
Or Stefan, yeah, okay, it's the same. We again have the voice issue. I think he has a bot in his room. This is a typical example of a bot that is putting noise.
Yeah, I think, yes. It happened again, Stefan.
So I guess he will be closing his application and opening it again. Yeah.
Okay, so good, that's good. I can start and then Don can add some words if he wants. Thank you very much for being here in this workshop, the fourth BotSE workshop. And I think one of the questions that we always ask at the end of the workshop is if you want to continue and have another BotSE workshop next year. So we want to hear your opinion. What do you think? And how we can continue. If you have any suggestion for the next BotSE, so feel free to add that. Is there someone that wants to talk?
I think the workshop was great. So definitely up for next year. I actually don't know if you've done this in person at any time in the past.
Yeah, the first one was in person in Montreal, 2019. Yeah.
So yeah, I think it seems that you know, the COVID times have been around for as long as I remember.
Yeah.
So yeah, I mean, it would be great to continue this and to have it in person again. That would be awesome.
Perhaps one of the other questions that we could consider is to see, but that's not my personal view. We could either the possibility is to just have like BotSE workshop as it was before, specifically focused on bots, or to generalize it to other kinds of automation as well. Just something in the back of my mind. So bots, if you look at,
I'm sorry.
So if you look at having a workshop like this one in the next years is definitely something that can be continued, because we had enough submissions, we had enough papers. But like from my personal point of view, for example, I will just say what I'm getting at. Like these things like, okay, today, for those that know GitHub Actions, is there such a big difference between using a GitHub action and a bot? Actually, well, in most cases, basically the GitHub actions, they are also labeled as, I would say, as bots by GitHub. Well, not the GitHub actions, but more the workflows. So perhaps it's probably related to what is the definition of a bot, and how far can you go in defining and considering something as a bot or not. So this would be more like related to what are the exact topics, focus topics that like the next BotSE workshop, if there is one, if the audience thinks we should have one, should focus on. So I don't know if you have any thoughts on this. First of all, basically thoughts of, is it good to have a next edition, and what would be like the main points of main topics that could be addressed in that next edition? Knowing, of course, that the topics that will be addressed will be based on whatever someone submits to the workshop, right?
Yeah, hello. I have an opinion on this. Hey, since I'm part of this workshop from the very beginning, and I think it makes sense, but it's in my opinion less of a question what we should discuss, more of a format question, because
we should not forget that there are a lot of conferences and some famous ones on human-computer interaction. And they also, this community also noticed that bots are a topic. And if we, in the long run, compete with this workshop, with a conference that is more prestigious and so on, I think the advantage of such a workshop is that we can have discussions and a lot more discussion and discuss ideas and I don't know. So my proposal for the next one would not be to focus on specific topics. I think the authors of such studies, they are able to motivate their work. That's not so much an issue, I think, to identify the relevant topics, but to maybe have shorter talks and more discussion and I don't know, things like that. Because then it feels more like, okay, we are a community, we discuss things, maybe even collaborations emerge, something like this. And then we are a bit different than the human-computer interaction conferences, right? That's just my feeling that we at some point will compete with them, and then it becomes difficult to attract people to submit to this workshop if it is the same basically as a conference in terms of format.
Mm-hmm. The main thing of discussions is that it tends to work much better if you have like a live conference or live workshop rather than a virtual one.
Yeah.
So that's also something to consider. But I think we all hope that the next series of workshops we will be attending will be live.
Hopefully. Any other suggestions for the format of the workshop, or I don't know? No.
Well, anyway, you have our email addresses. So if you have any specific things, ideas that you think you would like to see next editions of workshops, feel free to drop us a line. We are very open to any ideas on this, and then we'll see how it goes next. I would like to thank all of the participants today, and all the presenters today of their great talks and the nice discussions we had. Also the invited keynotes and the invited tutorial speakers. Thank you a lot for all of you for making this a great BotSE edition. I really enjoyed it. I also hope you enjoyed it as well. And of course, thanks for my co-organizers, Stefan and Mariatta, of course.
Thank you.
So with this, I guess, except if you have any like closing words, Mariatta, I guess we can close the BotSE session.
Yeah, we can close. I just want to say that thank you again. And as Stefan mentioned at the beginning of the workshop, if you want to contribute, you can also send us an email, and then we can collaborate for the next edition of this workshop. Thank you.
Thank you very much.
Thank you all.
Thank you all.
Thank you.
Nice.
Goodbye, good night, good afternoon.
Thank you, everybody.
Thank you.
Bye.
Bye.
Thank you. Bye-bye.